All right, let's see what we got going on here today. We are going to do labs, and we are going to work through the workbook that we have, and I'm going to give you guys a little bit of a view into how, I guess if I had to start over, how I would want to go about learning Linux. You know, most of us learn this stuff in the wild, so I think it's good to see maybe like a structured way of looking at it. So on the left, we've got a Killer Coda shell. I will link this to you guys. This is a free site that will drop you in any environment. We have a bunch of labs that are set up out there that you guys can do. And then the book just kind of follows along and gives you more commentary about that and more stuff to think about. So if you want to do this with me, you can. And let's just get right into the lab. So this first lab says you're a new system administrator at a company. You got the job, or maybe you fell into that role from somewhere else. You've been tasked with finding out information about a set of servers that has very little or no documentation on it. That may be, again, one of the most accurate things that I could do to prepare you for the industry. There will be things that you'll be asked to do where we don't even know what's going on, man. Like, nobody knows. There's no documentation. The servers just sit out there. Nobody knows if they've been patched. Probably more common thing than you'd think. And you might say, well, not in big companies, though. No, definitely in big companies. There's just servers sitting around that are not being maintained properly. So anyways, you find yourself at a command prompt. We got dropped into a shell of some type. We're not doing all the basics of Linux, or we'd talk about what that shell looks like, but we're trying to figure out some things about it. We're kind of assuming at this point that we know a little bit, right? We're at least at a shell. But if nothing else, you could type in the commands and follow along and kind of pick this stuff up as we go. So we need to know what's the release and version of the system. So we don't know anything about this system, but we might know to look in the release files. And the release files tell us about, this is an Ubuntu server, which is by Canonical. We don't need to know that yet, but Ubuntu is a pretty popular version. In early 2020, it got allowed. It maintained the DoD standard, so now we can actually put in DoD systems if we want to. I don't see it very often in DoD or U.S. government systems, but it does exist. This release is 2404. Here's some other information about it. It's on the long-term support version of that. But the reason we want to know this, because you might say, well, why would I care about that much? Well, you need to know the version of something you're on for. The same thing if you had something go wrong with your car and you wanted to look something up on YouTube about it. You need to know what the version is to be able to ask the internet the question. And it's the same thing here. Also, if this was a supported version, which it has to be for most projects and most companies to actually use something like this, when you go and say, hey, I've got a trouble ticket to the engineers that work on this, the first thing they're going to ask you is what's the version you're on. So this is a very important thing. Another thing is we're running inside of Linux a thing called a kernel. And if you do a uname-a, it'll give you all the information about the kernel, right? All the stuff that's kind of going on. But if you do something like a uname-r, it'll give you just the version of the kernel. And that's very important because it lets us know things about what the capabilities of the kernel are. And again, if we're going to go put in a trouble ticket or something like that, that's super useful to know. If I want to go look something up online and I find myself reading something that's really interesting to maybe a module or something, but it's on like the 4 kernel or the 3 kernel, the 3 kernel's still kicking out there. It's not going to be the same type of solution as something that's on like a 6 kernel, which is the newest version of the kernel, right? So anyways, we come down here, and here's the things that we can do. Here's the commands that'll kind of help us to know what the kernel version is, how long the system's been up. Well, how would we check the uptime of a system? There we go. And this server's been up for 2 hours and 7 minutes. And then we might ask, like, why is that important? Why would we want to know if a server's been up for over an hour? Or why would we want to know if a server's been up for like 3 weeks or something? There's a bunch of different reasons. The main one for me is if I get called out and there's something wrong with a server, I want to know that that server has either been up or rebooted recently. Like if that server's been up for 2 months and the problem started tonight, I'm going to go look at different things than if that server was just rebooted 45 minutes ago. What I mean by that is, like, let's say the server's been up for 3 months and there's a problem. I'm going to look for resource exhaustion of some type. Like we ran out of disk space. We had a network hiccup. We had high memory cause, like the out of memory killer, to start killing processes, I'm going to look for resource exhaustion of some type in that case. If the server's rebooted recently and something's not working, I might still in root cause analysis look for resource exhaustion to have caused it, but I don't think that's what the current problem is. Like the incident we need to solve is probably that something didn't turn back on after the reboot. And that's a very common thing. I would be checking boot logs, I'd be looking at dmessage, I'd be looking at all these things to see how the system booted and if those services were properly called or if they failed and those kind of things. So there's a bunch of things that can kind of happen here, but that all starts with understanding your uptime, right? So we come over here and, we just click in buttons here. And this one's really useful too. I like this one a lot. We might want to see how the system was booted. So assuming we have a grub file, right? And the system was booted from grub. One of the nice things about catproc command line is that's the actual command line that was used to call the Unix kernel, or the Linux kernel in this case, as it booted, right? So as the Linux kernel came up, this is the command line information that was passed to it. And you might say, well, why does that matter? Well, one of the reasons I like this is, let's say I'm looking at a set of like 10 servers and one server is a little different. Well, and that server's behaving differently. Well, now I have something to go dig in on why it's happening differently. Like, for example, I see that the root of this system, as this kernel was called, and as it booted up with this kernel image, which we also know ties back to the kernel that we're running, we see right here root is going to look for a label for cloud img root fs. So when the image is done, or when the kernel is done booting, right, from this VM Linux image, it's going to use root. It's going to do what's called switch root to that being the root of the file system. Well, I can go check to see if that's true. I can say df-h, and I can say slash, which is the root of the file system, is mounted on dev VDA1. And I can look at this and go, well, I mean, I guess, and we're going to get to this like in one of the future labs here in a second, but I'm just kind of showing you guys how we could kind of walk through and figure this out. And I say dev VDA1 is definitely not cloud img root fs, but what if that label relates back to it? And then we go and we dig in on that, right? So maybe we cd, we cd down into like dev disk and then by, and we see that there's a label. We do an ls-l in here and we see that VDA1 right here, which is VDA1 right here, is actually cloud img root fs as a label when we look at it by label, and look at that root by label cloud img root fs. Everything aligns, everything's like we expect, right? So this isn't necessarily like a troubleshooting course. I'm looking right here at labs and I'm just kind of trying to add some color to these commands, right? Because the commands are, look at the release version of the server, look at the version of the kernel that we're on, and that's semantically versioned, right? We use a tool called semver. Semver.org is a great thing to understand as an engineer, how semantic versioning works. And this is very common across all disciplines of engineering right here, some type of semantic versioning, okay? Then we come down here and we look at the uptime. Again, the uptime tells us kind of how our troubleshooting is going to go if something's wrong in our environment. There's a tremendous amount of information being shown here, so that's good to know. And then catproc command line will tell us how the system was booted. There's also another place to find this right here. It's dmessage, and then you pipe it through head. And the top of the dmessage, so right here's our dmessage. Right at the top of the information, it'll give us something about the kernel, and then it'll give us the command boot line, or the command line for the boot. That's the same thing that's in proc command line, right? That should always kind of align to. Hey, Technique Unknown, how's it going? We're just going through the lab here, and then we're talking through some of the stuff from our actual book. We have 3 books out there. 2 of them are for the courses, and then this one is just a lab book that kind of allows you to journal a little bit and go look at, more stuff about the system, right? How's it going, Akshunya? So did we accomplish our task, right? So right here it said we were new administrator at the company. Over here, my task was determine the operating system values of a running Linux OS, execute commands, and evaluate output of a running Linux operating system. We got a running Linux operating system. We can see that because of the kernel and all that stuff. We were given a bash prompt. see that? So we're in bash. We had 60 minutes. We've only used 12 of them approximately. And we walked through a lab at a pace that matches our learning goals. So I said, what useful information did you see from the command cat etc splat release? So we did that command. And I might also show you this, just in case anybody's wondering, why did I use a splat there? Well, ls-l will show you that I actually catted out two different files here, but the reason I use this, the reason I show you guys this, is because across all versions of modern Linux, whether it's an etc OS release or etc rel release or etc whatever, or etc in this case LSB release, you're going to catch the release information you want. And you might say, well, Scott, couldn't you have been more precise to the exact operating system you wanted? Yeah, we absolutely could have. But sometimes you just want to get the information and fucking go about your day, right? You don't want to be sitting here dicking around. You like the minutia of a thing isn't nearly as important as the outcome when you're just getting through stuff and closing out trouble tickets and trying to move on with your day to more things that are more interesting, if that kind of makes sense for you. So we did that. We found etc splat release, and then I said, what information would you see about the kernel with uname-r? And then I said, look up semantic versions and why this might be important. So we looked up semantic versions, but uname-r showed us about the kernel. uname-m focused on just the architecture of the kernel. And uname-a gave us a lot of information that, again, might have been useful, but a lot of times when people are scripting and want to make sure that a kernel's to a certain version, they'll match something with against a uname-r, and then they'll maybe pull that apart or something. There's a million examples of that out on the internet, right? We're not really worried about that right now. And uname-m is a very common way to make sure that you're at least on a 64-bit architecture system. But anymore nowadays, you're almost always going to be on a 64-bit architecture system. However, ARM systems do exist, right? So we do have systems that are doing more and more of these there are other types of architecture that are out there that you may run into in the big systems and like big data and enterprise for Linux. So you might run into that. Xshun, you said judo all Linux into me. Yeah, so this is what we do, right? And then I say right here, why might you care about uptime? What information is shown in those last three numbers and why is it important? So we do the command uptime and we get that the system's been up for 2 hours and 15 minutes. So again, that's a useful thing to let us know if the system's rebooted in recent time. We know this system has, or it's booted recently. And then we have the 1, the 5, and the 15-minute load against the processors. So how might we find out a little bit more about this? Like if I didn't know anything about this uptime, maybe I could man uptime and I could go see that it says that the system load averages for the past 1, 5, and 15 minutes are right there, right? And sometimes I've shown you guys this. We can actually go test this a little bit, right? We can move this over here and I could say, okay, while true, do uptime sleep 3 done, and this system will forever until time stops or until the server breaks and power drops to it or it gets rebooted again. It will forever loop in this fashion, always finding true to be true, going back into its block of code, doing an uptime and a sleep, and then coming back and evaluating true to true, and it'll loop like this forever, right? Let's go spin up some load on this server for a second. So we go jump over here to a new tab. Make the tab a little bigger for you guys. And maybe I say apt-y install stress. Stress is a tool that'll stress our system. It'll just add load in different areas. So maybe I type in stress because I don't know how to use it and it gives me a bunch of information. And right here it says that we can do the number of workers spinning up on CPUs. So maybe I say nproc to see that I only have one CPU in this box. And I go, okay, stress-C4, we'll just pretend that there's 4 CPUs and go hard on it. And the timeout will be 180, right? So that's gonna spin up stress on this box. And if I come over here, we're immediately gonna start to see the 1 minute load average move up very quickly. The 5 and the 15 are going to be much more sloped because they're a sliding window over a longer amount of time, when the load of the server was almost nothing, right? So we're going to watch this system spin up pretty fast in the 1 and then slower in the 5 and the 15-minute time frames, right? So why might you care about uptime? Well, because uptime will let us know if there's an incident of like high CPU load still happening, if it's recently started happening, or if it's been happening over time. There's a bunch of information that we can extrapolate out of the 1, the 5, and the 15-minute. When I used to work with web servers a lot, web servers will get hammered and then they will stop getting hammered. And sometimes you'd get there and you'd have a really low load average in the 1-minute sliding window because it's already cleared whatever the event was, but your 5 and your 15 would still be high. Well, that means you probably missed whatever was happening in your servers going back to like a normal state, right? But there's a lot of stuff that can kind of be interpreted out of this. And it's not the end-all be-all tool as far as load usage goes, but it is a good one to see. Is my system experiencing a higher than average load? Now watch, this is going to finish up here in a second over here. And when it does, we will immediately know because this will start dropping back down. So we see we're hitting about 4.69, we might even hit 5, and then it's going to drop off and start to come back down. All right. Actually, I didn't move that one over. That's my fault. Let me go fix the YouTube side of things. Apparently, I did not save that. Yeah, sorry about that, guys. On YouTube, it should read now the Back to Basics Learning Linux. We're just doing labs on Sunday mornings, right? That's what we do around here. We did the deploy of the website yesterday, so that was my fault. What are the kernel parameters? Yeah, we look at the kernel parameters if we want. This one doesn't have much pass to it, but I can show you when it's done. This thing's almost done. There are a lot of kernel parameters. I will show you the ones that I know that are more common. CMD line. These are some pretty common ones for like Red Hat type systems. Here's our boot image. So where's it gonna get the? That's the kernel that I'm actually running on this older box. So look, this is a 3 kernel. It's old. This is an old CentOS 7 box that doesn't. This isn't in production anymore for people, but it's in production in my home lab. Here's the root is switching over to dev mapper CL root, which is a logical volume management style disk on my system. It's RO typically means read only. And then we've got a crash kernel set to auto. You can set crash kernel to a bunch of different things. You can set a certain amount of memory to be allocated and disk space where you want to store if the kernel ever crashes. Here is our /root is mounted separately apparently, and /swap is over here. Yeah. These are the ones that I'm more used to over here at the end. The RHGB and the quiet. Quiet basically does like a very quiet boot, doesn't throw a lot up to your normal terminal. A lot of times we'll turn that off for troubleshooting. And then one that I almost always like to throw on my systems that are attached to SANs, storage area networks, is fast boot. Because what fast boot does is your system doesn't query all the disks, and it doesn't do any scanning of those disks. And you really don't want that. If you're attached to a storage area network and there are like 100,000 disks on the back end somewhere, you don't want a system booting and scanning all of those. That's not a good thing. If you said, what are all the kernel parameters, you'd have, oh, look here, this is dropping off, by the way. You'd have to go look them up, probably. All the different kernel parameters that you could use, there's a lot of them. And most of us do not ever find the cause to use all of them. And I would also tell you, you got to be careful when you play with these, because often I tell you guys, when we do stuff in the corporate world, we do it in a supportable fashion. If you start setting a lot of kernel parameters on your boot, you may be voiding whatever, Red Hat or Canonical type license you have. And what I mean by that is they are they are contractually bound to support you if you're paying them for certain types of the OS, but they may have a clause in there that if you're changing a bunch of shit and making it run weird, that's on you, right? Like I always tell you guys about the EPEL repos. If you just drop EPEL repos on everything, you can't guarantee everything that you have in there is supported by your vendor. So you do have to, in the corporate world, you got to play this game a little bit. It's the same thing. It would be the same thing if you bought a brand new truck and the first thing you did was go home and cut all the springs on it. And you're like, well, I wanted my truck to sit a little lower. And you're like, you better not take that back to the fucking shop you bought it from. They're not going to support that. You cut all the springs. What are they going to do? They're going to have to put new springs on it if you ever tell them to do work, right? So my point is you void the warranty on things, right? And it's the same kind of idea with that. All right. Anyways, what information do you see from catproc command line? Why might this be interesting if you're running a fleet of servers? Well, it's just you can see if the servers are all built the same. Super useful for me. If I go run this against a bunch of servers, do I have a... I think this is one that doesn't have node 01. Yeah, this one doesn't have node 01, so we can't go in them. But we could see that both of the kernels on the two servers, if we had the two-server environment, were exactly the same, and that's super useful. I said, when you look at this system usage, is this server under high load or not? Currently, it is not under high load. That's a pretty low usage for a system. But if you wanted to know kind of like the more technical answer to that, when you do an nproc or you do a catproc CPU info, however you want to do that, and you see in this system that you only have one processor. You only have one processor, it's processor 0. You just have the one. Is this system under high load is read like this. So this is wait time for a kernel. And if I have one CPU, wait time for a CPU, not for the kernel. When you look at this and you see 1 here, anything less than 1 is no wait, or there's not wait. It's not waiting for access to the processor. However, if you are over 1 here, and this is 1 is the number of your CPU, then that's bad. You're starting to have wait. Not bad. It's just your system's under load, right? Your system's waiting, and runnable or blockable processes cannot run against the CPU until they get access. Now, if I were to do an nproc here and see that this machine had 256 cores, which is common in some of the servers I work in, and I saw over here a load average of like 46, I'd be like, I don't care. 46 is way less than 256. I know that we are not waiting for processors. The system is not waiting for processors. Now, that does not mean that their application, the application you're supporting, isn't having problems, because all of the application can be reaching for one processor. You know, it's not multi-threaded or it's not parallel in any way, and that would be on the application, right? But we could go see that happen, and I show you tools in later labs and stuff how we actually watch a process if it's going against one CPU or multiple. But that's something to think about, right? So when looking at this system usage, is this system under high load? Sure is not. It sure is not. It is not doing anything. It's chilling. I said, what user is running the majority of processes on this system? So let's go look at that a little bit. We go to the next part here. And I say let's dig a little deeper. And on this system, each command, let's look at the VM stat. So VM stat. And if we say 1.5, it'll give us a VM stat run against every 1 second to see what's happening in the server. So if we make this a little bigger so we could read that. There's a bunch of things that are happening here with VM stat, but by default, if I just say VM stat 1, it'll give me every 1 second in perpetuity. If I stop it though, and say give it the end, so that'll be the step and the end, this will be every 1 second for 5 seconds. And if I said give me every 5 seconds, so now the step is 5, so every 5 seconds for 5 times, so every 20, for a total of 25 seconds, we can see this. There's a whole bunch of letters and numbers and stuff there, and you're probably like, well, what do all those things mean? Well, in the background of this, I actually have a presentation behind this that's on Linux Systems Administration. We're not going over the presentation right now. We've done it many times before. If you guys need to find it, it's actually up in the Discord as well. But let's go look at what this is showing us here real quick. Here's VM stat. So here's the runnable processes. So number of processes running on the CPU, value greater than the CPU count is called saturation. We're starting to wait for CPUs. So if I have any number 1 or less here, I'm okay because I have the 1 CPU, right? The blockable, B is blockable processes. We don't have any, so that's fine. Nothing's waiting to get to the CPU. Then free is the free memory in kilobytes, so I could sit there and count on my fingers and figure out how many megs or gigs that I have, but there's other ways that are better than that. SI and SO, this is a bane of a lot of us systems admins and systems engineers. We do not want things swapping in or out of our system. Once you start to swap, you're going back to disk and you are immediately slowing down whatever thing's happening. So while that exists and while Linux kernels still want to swap, and while there's still a requirement like Oracle, servers that are running Oracle database still have to have swap assigned, we do not want to be swapping ever in a Linux system. It's just, you're going to be like, it's almost like you're eventually going to hit a wall. You're either going to run out of processing speed or you're going to run out of swap space, but running out of swap space is just, it's a problem. It's a massive problem. So we really don't want that, especially in databases. If I have to use a swap space, I will actually carve memory out from I will use memory as a RAM disk rather than actually using swap off of a real disk because it's too much of a problem. So I show you guys how to do that. Not necessarily in any of these labs because we don't have access in here. I've shown you guys how to do that before down the Discord though. So, okay, breakdown of CPU time and average of all CPUs. There's information over here about what's going on, system ID. There's all these different calls, and system time, user time are the two different types of calls that you're going to run into the most, and then idle and wait IO. So if things are waiting, right? So you can see what's happening with the system here is the point, right? This is what we see with the VM stat. All right, let's pull this back up. Okay, and then I say MP stat 1.5, and this will go every 1 second for 6 total seconds. This will tell me how much of my system, let's make this a little wider, how much of my system is being used. And this is the same information from up here. It's just being read a different way. And it's going against all the CPUs, and it's telling me how much of them are being used. And if we were asking very high level right here, if the system was under a high load or not, what do you guys think that is? Do you think that's a high load, or do you think that system's chilling? Just chilling, right? It's not doing anything. However, we could run MP stat right here, right? We could watch this MP stat, and we could go back over here to our stress, and we could rerun our stress, and then we can come over here and see the change in our system immediately. Do you guys see how it flipped to immediately being very high load? We could see that there's a tremendous amount of load on our system right now, and it's all coming from the user space. It's all user space calls, which, by the way, becomes important later when we're troubleshooting, but not for right now, not for this level. All right, so we know that's going to spin up the system for a little while. We can actually come over here and kill it, right, if we don't want it to do that anymore. And over here, we'll immediately see it go back to chilling, right? All right, so we see that, and then I say one of the questions was, who's using a majority of the processes on this system? Well, we can do a PSEF and see all the processes because we're the root user. We know we're the root user because of ID and who am I, right? We can see that we're the root user. But if I do this command like this, where I do a PSEF and I can see everything, that's kind of a big old mess, right? Like, do you want to try to count those all up and figure out who's the UID that's doing the most? Let's make this a little smaller. Who's the user ID that's doing the most? I don't want to try to count that up. So I'm going to let my system count that up for me. I'm going to say PSEF and then maybe do like a more on it. And I go, okay, I've got these lines over here and I've got these individual columns. And maybe I want to look at only the first column, right? And this will print, oops, you gotta put these guys in there. There's an example over on the left too if you need it. But okay, that did that, but that didn't either organize them or count them for me, so that's not super useful. So what I might add to that is I might sort them, and then they'll all be near each other, and that's okay. But then maybe I want to also unique them to see the unique users or users and user ID, but that doesn't count them, so I add a -C, whoops, -C, and it will actually count them for me. And looking at the server, I would very quickly say, well, almost all the processes are used by root. And I knew that the system wasn't really doing anything. It's sitting there idle. So I'd say, no, this server is not really doing anything. The server doesn't probably have any application running on it. It probably is just a server sitting there turning electricity into heat, right? That's all this thing's doing for right now. So come down here and I say, we'll get to networking here in a second. Let's come over here to PIDstat. So what does PIDstat do? This is going to show us the process IDs and what they're running against as far as the different CPUs. And you might have to play with this a little bit to get this to the right size for the way that you want to see it as an output. I think that looks like a nice little output there. But I've got the user ID here is 0, which is root. How do I know that? Well, because when I did ID earlier, I saw that I was root, right? I was the root user, and the user ID for root is 0. So here's the user ID that started all these processes. Again, this box is basically just running root stuff. There's nothing else going on. And then I come over here, and here's the process ID. So I can go expand or attach to and watch those processes run with strace or ltrace. I can see a bunch of information about what's going on. But here I can also see what CPU they're running against. This is tremendously useful. This is what I was telling you guys. Like, I've had people tell me, like I've had application developers on teams, of which I've supported hundreds of them over the years. I tell you guys, when I worked at AAA and I was the platform engineering lead, I had about 200 dev teams that would come to me and ask me questions and stuff. And sometimes they would insist that they had a properly tuned application that was, you know, a Java app, almost always Java. Black box to me, I can't see it. It's just running on top of my server. But I can see that it's only consuming one CPU. It's not threading out across multiple CPUs because only one CPU is being used. This happens. Stefan said, I recently ran into a server issue where I want to share here. The server had a full CPU utilization of 72 cores. I noticed high I/O wait times on some logical volumes, likely connected to the SAM. What tools do you use to analyze this information in the system? Do you have any tips for me? Yeah, Stefan, I would use, if you have IOstat, you can see what's happening with the individual reads and writes. So a lot of times, let's say I was just watching IOstat here, I can see the reads and writes into the system. Another one that is kind of actually nice if you're watching the event happen, I don't think I have it on here, but ATOP. ATOP will show you everything that a process is doing, and you can either use ATOP in the background or you can watch it live. I'm not normally a big fan of like top and watching systems, especially with like ephemeral data that's going away. But if you're writing it to a log file with ATOP, you can go and like replay what was happening in your server in like steps. And mainly for me, especially if this was happening a lot over time, you would probably find that your IO was shooting high at some point. You can also you can actually do an strace down on the systems. You can strace on the applications rather that you know are writing out there, and you can see when they start to spin and start to make calls. And then strace by itself. So let's say I was just watching a process. Hold on real quick. Let's find a process on the server. In fact, we can just add a process. apt-y install Apache 2. Right. Let's just start a web server on here just for fun. It's outside the scope of this basic first lab, but it's fine. We'll just make a web server. And we'll start the web server running. So systemctl status Apache 2, right? So it's running. So now I've got the PID, but if I didn't know that that was the process ID, I could find it. I could do psef grep for Apache, right? And that would find that Apache is, you know, one of these. So 4051 is the one that we want to look at right here. But also other ways I could have done it is I could do an ls, so let's see, ss-ntulp, and I would find my web server, which is port 80 right here, and I would see that that is one of these many Apache things, but here's the Apache 2 PID, so 4051. Now I can attach to that PID and watch what that process is doing. So strace dash P4051, I think. And now we've locked our terminal, but now we're just going to watch what that web server is doing. And now if I could hit that web server and do certain calls, I could see what's happening within my web server. So it's kind of like I'm opening the log back here. That's not a log though, it's the actual process running. We could have the log open as well, right? That's the log of things that are happening. But we're watching this basically do nothing right now. If we started to make calls into the web, we would see this service going and opening files and doing all these things, touching that back end stuff. Well, what would happen is if something broke, we would start to see things spin up. Now, this will scroll the screen so fast you're never going to read it with the human eye. But one of the nice things about this is you should have, I want to say it's an S. Let's see. It might be dash S or it might be dash capital S, I think. Nope. Hold on. I do not remember what it is. So here's what we do. We do a man strace. Whoops. We look for summary. Dash capital C. Yeah. So we'll do the strace with a dash capital C on it, right? Now, this will still show us the web server, right? And let's say that, use HTOP a lot. I think HTOP's probably fine. I use BTOP. Like when I show you guys the our backend like LLM thinking through things, I use BTOP for that because I think it has a cool little output when CPUs spin up. But let's watch this real quick. Again, still our server's doing nothing, but let's say something was happening and causing this server to spin high, and we started to see all this stuff happen. And again, our tiny little human brains can't process all the scroll that would be happening. And then you hit Control C, and it gives you the summary. And the summary is super useful because maybe you've got two web servers to compare, and now over the course of a minute, under this certain load condition or whatever condition, I can see what was happening with the process, and I can see that like over on this one that handled the problem fine, there was nothing, but over here on this one, as you know, the load started to come up, it started to churn through system calls back to like our SAN or something. Right? Our IO was just got shot. Now I'm gonna back up for a second and tell you, if like as a systems guy, right, as a Linux and server engineer and a guy who wants you guys to get into doing this stuff professionally, I'm going to tell you as the Linux side of things, the Linux admin, if you brought in a truck, right, and you're like, hey, when this truck goes 55, it just starts to shake. And then I'm like, okay, it just starts to shake. Fuck it, we can troubleshoot that all day, but with a server, for sure it's cheaper with a server, I'm just going to replace everything. I'm going to say, like, anyways, where I'm going with this is I'm going to check to see what's different and the same between the two servers, and I can almost guarantee you there's a different version of a kernel or a different driver, something didn't get updated, because two servers that are accessing things the same way, barring some kind of hardware error, which also throws other types of logs, there's probably something else different. Does that kind of make sense? So, like, I'm a guy, I tell people, like, a lot of stuff I do is very simple. It's like Sesame Street. One of these things is not like the others. One of these things just isn't the same. And you find a broken server, and I'll find you something that's different on that server that is related to the problem, and we fix it, and maybe the problem goes away. And so I'm not saying that that's for sure what happened there, but what I'm saying is you can use these tools to watch what's happening in the system at as close to the actual system calls as you want. But again, there's too much information happening here, so you need to like summarize it at the end. And there's also tools like eBPF. There's some really awesome tools. And what I would also tell you, there's another thing, Stefan, because at the end of the day, you need data to make decisions. You can't, otherwise it's just like, well, it feels slow. Well, it doesn't work, right? And that's not good engineering. So the closest I can tell you this is this guy, Brendan Gregg. This is one of the best places to go. He's got a couple of books. They were actually just up on Humble Bundle. I'll link this to you on the YouTube side and on the Twitch side. But this is one of the best things. So, like, how do I get as close to the I/O, like out to my disk controllers as I can? Here's the types of commands I might run: iostat, biosnoop, biolatency, biotop, block trace. I don't even know all of those commands. I use iostat often. The systat tool stack is just awesome, and some of these I don't even know. But I would find them out and look at the data and then start to either compare historical data that I'm hopefully tracking or this between a good system with a bad system. Now, if all your systems are doing it, we may be we always look at this, right? I always tell you guys this in the systems world. We always look at utilization, saturation, and errors, right? That's called the use methodology. We've been over this before, but I'm just showing you guys, like, utilization is between 0 and 100% of utilization of some process or some system, right? Saturation is when a line starts to form, or a queue, as we call it, like a queue, and then our errors start to drop out of that, right? Errors start to form as queue times and timers and timeouts start to get hit, right? All right, so yeah, hopefully that stuff's somewhat useful to you. Let's go back to where we were. So I'm just showing you guys, by the way, this is actually the lab book that I have up on LeanPub, and this lab. So the labs over here you can do. We're still on the first lab. We're kind of going far afield, but I think this is good for you guys to see. And there's just so many ways that you can take it once you start getting into Linux and learning it. But we're kind of assuming today that maybe you're newer to Linux, and we're going and we're touching these different pieces, right? Here's another one. This one's excellent. IOStat XZ. One of my favorite things about this is you're watching this and it doesn't show any output, right? So it showed some output up here. It'll actually show you all your disks. Then it will only show you the things that are actively working. So let's say you do have a SAN with like 100 disks. The very first output of IOStat-XZ1 would show you all of those disks, and it would be a big mess to the screen. But then every one after that would only show you the ones being used. So like this right here, if I just sat here and crossed my arms and watched this, right? We're just sitting here, we're like, okay, this is the system. That system's chilling. There's no disk I/O right now. There's no anything. The CPU is almost sitting completely idle. But when something does write back to the disk, we'll see that disk pop up right there. So this is kind of a nice one for like a heads-up display. None of these ones here are as good as this in the long run. In the long run, you've got to be able to go to something like this and see your historical usage, right? You've got to be pulling data out of systems and looking at that. And that's a big part of like our Linux sysadmin course, where we talk about like, hey, you need to be making decisions based on like current data, but also looking at historical data to see how well your servers are running. All right, anyway, so there's all that. And let's see that. We're going to dig a little deeper into networking now on this one. This is still the first lab. And I say do each command and think about the output you're looking at. You may need to run them multiple times. So this is the SAR command. And it's just looking at the devices in the system, right? SAR-n dev 1 to 15. And it looks like this system is mostly chilling, right? It's not really doing much. I don't see a lot of receive or transmitted packets, and I don't see a lot of received bytes. And those are those are bytes because capital B. And transmitted bytes, I don't see a whole lot of that on the loopback or the ENP1S0 interface or the Docker interface. So we're not doing a lot. Back to our networking there. And if we were to look at this real quick as like Linux people, do we know which of those three interfaces, either by name or by some other method, are the way that we send packets by default out of this device? Do we know which one of those it is? Well, we might know by name that loopback is always only connected to yourself. That's a TCP IP standard, so we might know that. And we might know Docker is always internal Docker space, so we might know that. And then ENP1S0 is kind of a funky name, but that's most likely the name of a Ethernet address. I can find that. I can say IP, BR, ADDR, and we can just see the IP addresses that are assigned to each of our interfaces. Now, you can do IP adder by itself like this, but I find that that's like a little more noise. The correct information's still there, but that's a little noisy. So I don't always show, like if I was trying to prove something to myself, that -BR is like one of my favorite things. Just IP -BR ADDR. Can't do that in any other order, by the way. You can't do the IP adder and then BR after. It doesn't work. Which is kind of annoying, but IP-BR, so that's brief. Well, that also doesn't quite tell me how I send information out. I probably need IPR or routes, right? Route. These are different commands that will then tell me if my system wants to send something out, and we're not really doing networking right now. We have another lab that hits on networking more, but I can very quickly see that my default route is through 172.30.1.1, and if I'm going to send stuff to 172.30.1.1, I use this interface, ENP1S0. Which, by the way, I could have also deduced by looking at loopback is only connected to myself, and Docker is only connected to 172.17.0.1, and that doesn't make sense to leave my network because my device over here is 172.30.1.2, and that is on the network that allows me to connect out. So, like, we can learn these things and figure these things out, but they're very simple commands to get that information to ourselves. Sometimes you get to a server and it's broken and the networking is busted because somebody tried to bond some interfaces or something and didn't know what they were doing. Or they just use some, I mean, nowadays Chat GPT, but I was going to say like some old thing off of like Stack Overflow and they didn't check to make sure it was correct. And maybe it worked then, but it's not going to persist through a reboot. That's the most common thing in all the world. You know, you go to Uptime and see that it's recently rebooted and the configuration that somebody had built broke. That's a very common thing. People build janky things that are what we call non-persistent, right? Doesn't survive a reboot. And then look here, we can go see that same thing again, but now we can also see any errors. So if we're getting any amount of errors in TCP/IP, we can see them right here, so we can see if our TCP connections are stable or not. This can be very, very important for connection back to like storage, and especially if you're talking to things and backing stuff up to the cloud or something, you're using secure networking, right? You're using some kind of transport layer security. If you're having a lot of retransmits and errors and stuff like that at the TCP layer, it would show it right here. I don't think in my career I've ever seen high things here. I just know that anything here is not great, right? You don't want a lot of retransmits. That's not good. Anyway, so that's that whole lab. Digging deeper, I say read the manual for PS. So man PS and see what other information you can see. Are there options that you can save? So I'm a big fan of reading the manuals for things if you've never seen them, right? Report a snapshot of the current processes. PS accepts several kinds of options, right? You can go look at them. My most common one by far is PS-EF, but some people love and swear by PSAUX, or in this case AXU. The order doesn't matter. You can look into threads. I probably should learn some of these other ones. This one I use often, PS-EO, and I want to see like lstart CMD. So when was the process started and what was the command used to start the process? And then I also typically want the user that started it, and then the PID and the parent process ID. So this one right here, PSEO. So I'll use this PS-EO, and then I'll want lstart CMD UID, parent or process ID, and parent process ID, right? And if I do this, it'll give me all of these, but just think about this for a second. This is one of the things, like if I'm getting called in the middle of the night and I'm like rubbing sleep out of my eyes and I'm like hearing that a web server is busted, the two things I'm looking for is the uptime of the server. When did the server last reboot? Because that'll give me some type of indicators. But what if the server rebooted like 3 months ago and you go, I don't have that anymore. I can't say that it was something that didn't restart, so it's probably not that. But what if I come here and I find that like that Apache server? Where is that Apache server? He should be right in here, Apache 2. And I find that he was started more recently, like maybe on Friday he got restarted. Why the heck did that service get restarted on Friday? Right now I got to go look, and maybe I find out that somebody made a change there, and I don't know, who knows why they changed it. But then they added it back into load balancer without testing it, and now like our users are having like 1 out of every 20th user is having some type of weird problem because they're hitting that version of some server that's busted. Now, everything I just said there is bad practice because you should never be putting anything directly back in without having gone through your CI/CD pipeline. But I guess I'm just talking about like historical problems you may still run into if you're not in like a company that does good CI/CD. Where's that web server? Anyways, we would see it here. Why don't I see him? I think I'd see. Help if I grab. Yeah, there's our web server. So anyways, then I can see information about that. And you might say, well, how's that different than like the PSEF that you did? Well, it's not much different, but you get slightly different pieces of information about it, right? Maybe you want it to look a certain way for whatever. All right. Other useful thing. Oh, there's another useful thing. I don't know if you're still around, Stefan, over on the YouTube side. There's one other thing that might be kind of useful. Let's say back on this web server here that I'm looking at, ss-ntulp, right? And I see that I'm 4051, but there's individual threads underneath, and that's probably fine. But I can do an LSOF on the process, and I can look at the process 4051, and at any slice of time, now this is a slice at that exact time, I can see all the files and all the pipes that process is holding open. Now you might say that's weird or that's not that important, and I say, yeah, maybe it doesn't, it's not super interesting, but it may be useful if you, I don't know that somebody had updated one of these modules. You find that one of these modules has been changed recently, and then you're like, that one application is touching that module. That could be useful, and then you're like, well, that's why this thing isn't behaving the way that it's used to, because any of these look, these things don't change often, but they do change, and they do change, especially on a patching window, and sometimes people will patch a server group and not reboot it until the weekend or something, but the way that server is holding open those libraries absolutely matters to whether or not it continues behaving the same way, which is why a lot of times we'll reboot. So a lot of times you reboot servers just because of the services. It's easier to get all the services to restart and take the new libraries. But anyways, my point is, if you were ever questioning like what a process is actually touching, LSOF is a great tool for that. LSOF will show you, it's a list of open files, but it's not just for a directory. Normally we use it for a directory. Like I get a trouble ticket in, or I'm working with one of my junior guys, and they've got a trouble ticket to like unmount an NFS share and remount it to a new location from a new, maybe we backed it all up, and then now we've got a newer backend Isilon or some type of backend service, and we've got to take our Linux system that's running live, and this is always a problem, but take it down on that one path, that one mounted file system, and move it over there. That's a hassle and a nightmare, and you really don't want to do that during the day. You want to do it during planned outage and stuff. But let's just say it's like an emergency and we have to cut over. And one of the things we'll do is try to cleanly remove all the users. So we'll use like an LSOF against that to see what processes and users and other stuff are in that directory. And again, you try to tell users, but man, I'm telling you, if you've got 100 users and you put something out like every day for a month, you will still, when you take that service down or make it unavailable for 15 minutes or whatever, you will still get 10 emails from the people who didn't read whatever the thing is. That is like a truth of life. Like, it does not matter. People will be like, I didn't know the bus schedule. I didn't know the whatever. It doesn't matter. People aren't going to know what you put out. So anyways, all right. Then right here, I say go out on your favorite search browser or take an internet safari to read about common releases of Linux OS. Can you find an LTS version of that OS, and what does that mean? So maybe we come over here and we say Rocky Linux LTS. And here's our Rocky Linux release and version guide. The reason I pick Rocky, guys, is I like Rocky Linux. I think it's a good tool. They're also the guys who support Werewolf, and I've done, I think I told you guys in the last year I've released probably built over 15,000 Linux systems for the government on probably about 10 different projects, and all of them were Rocky. Well, all of them were Rocky. One private company I've done some RHEL for. Other than that, it's like been Rocky Linux heavily getting deployed because it's a supportable version that's alternative to Red Hat. It's also under the same vein of Red Hat, so you get the same skills and some of these other things. All right, so anyways, here's the versions and the support, and if they're supported going forward, and when their end of service life is. So, end of service life for Rocky 9.5 is June 4th of 2025. So we've hit that, and now we're supported on only 9.6, right? Which is actually what we run in the home lab. And then over Rocky 10. Here's the Rocky 10 and are they supporting it on this version of the kernel? 6.12 kernel, by the way, newer even than the one that we're on. We're on 6.9 in this lab, right? We know that because we saw it earlier. Yeah, users be users. I had an old saying that if you make something idiot-proof, they'll make a better idiot. That's just like a fact of life too. Right, here's the timelines and stuff. I think this is pretty good, and you can find those for RHEL, LTS, right? And RHEL doesn't really. I don't think they have a designator for LTS. They just support what they support. But here's the maintenance support and cycles of like a Linux OS from RHEL, right? The extended life cycle, ELS, they can cancel us at any time. It's in the contracts. That's untenable for most government projects, so they leave. Most government projects won't stay on an ELP, extended life phase, where the vendor can just stop supporting it whenever they want, and that's in the contract, so then they have to get off of there. I have not seen, Chinkopus said, is Alma Linux one that is used as well. I have never seen Alma Linux deployed in an enterprise, but I will show you this, because I do have to give this nod. Alma Linux. I know that Alma Linux does have a support model, so I know that Alma Linux could be used. I just have not seen it be used. So hopefully that's clear. I'm not trying to shit on Alma. I'm just telling you I had not seen it used. They've got this support model, and one of the times I was streaming on here and we were talking about this, somebody mentioned this to me. That's why I'm kind of nodding over to it. But he said that like I think CERN is using it. So people in Europe or government entities in Europe are using this. I can't speak to it well because I don't know. But what I do know is they do have a compliance. They have FIPS 140-3, which is something that you would need to be government in the U.S. FIPS is the Federal Information Processing Standard. It's a very it's a very common type of standard. And then SIS and STIG. You guys have mostly seen me do STIG management and STIG stuff. And anybody that's like, well, how would I learn more about STIG? We actually have a free course on that, right? The security engineering course, which is right here. This course walks you guys. Oh, I was showing guys other stuff. This is the course right here. The books are free. They're just online. You'd go. This is a web page, right? Generated out of Git, and there's our courses. But these are all STIG backends. The STIG is the Secure Technical Implementation Guides, right? Yeah. So Alma is supported in some way, and I guess could probably be used in government stuff. I just haven't seen it on the U.S. side. I mostly work with U.S. government and U.S. customers. So, all right, there. I ran out of lab time on that lab, but guys, Killer Code is like one of the best free things on the web. I just used an hour of time for free. Like they didn't charge me anything. So we'll go to the next, and I'm looking through. This is the Prolog Big Book of Labs. This is available on LeanPub for people that want to spend $20, but you know you could just do the labs without it. It's just extra. It's almost like a journaling for you to reflect, and then I sometimes go through it like once every few months for people that want to kind of see what we work on. So this is we're going to do kernel checking and packages inside of our system. Is this the next one? All right. You're a new system admin at a company. You've been tasked with finding out information about a set of servers that has little or no documentation to it. I'm telling you guys, that may be the most useful thing that I can show you, right? Is that this is what your life's going to be like. You're going to get hired. Manager's going to be standing over you, super happy. He's going to get you into the first Linux system in the environment, and you're going to go, oh hey, do we have do we have a list or like something like somewhere where I can reference like all the servers? And you're like looking over, and he's going to go like this. He's going to go, oh you, and he's going to turn around and fucking walk out because now it's your problem. And you guys think I'm kidding, but anybody here that's done Linux work knows that the guy before you probably left you a shit show. And that's the best way I can say it, too, is you probably... Now, that's not always true, guys. I'm not saying that's universally true. I'm just saying sometimes, especially if you get in a small company and you're just maintaining like 100 Linux boxes that they run, like you may be the one that sets the standard going forward. You may have to stand up your own wiki. You may have to stand up your own GitHub, right, for your company. That may be things that you guys do, right? This might be your career. I've spent a career unscrewing things that have been screwed, right? But it's a good career, right? I think this is a great path. I'm not trying to scare anybody off from it. I'm just going to tell you, your task is to keep all these servers operational, to keep the uptime of the system as high as possible. You need to do that in a secure way, which we talk about security, You need to do that in a way that supports users getting on the system, because again, nobody runs Linux boxes. Like, no CEOs are all getting together and high-fiving each other because they've got their company to running 1,000 Linux boxes. Like, yeah, I run 1,000 Linux boxes. You ever heard that? They don't care about the underlying technology. They care that the system is doing whatever productivity tasks. It's facing customers and serving web pages, or it's, you know, whatever. They don't care about the underlying technology like we do. We're the people that support the underlying technology. Anyways, I don't know. I'm getting far afield, but let's check the kernel and package. So our task here, task condition standard. Does anybody know where that is from? Some of you know because you know me. But where do we do task condition standard? Our task is to learn some Linux kernel commands and understand package management. Let's see if we can do that at a high level. Given a bash prompt, complete in the allotted 60-minute time. Well, that's because they give us 60 minutes free, so we're going to take the free stuff. And then execute. You could pay for it if you want, but it doesn't cost you anything there. Execute and understand commands. Understand the command output for kernels and packages. Okay, boom. All right. So bottom line, uptime equals money. Yeah, the company looks at, can the customers interact with us and buy our things and make money? 100%. The underlying, like, if I report at the end of the year that my Linux servers were just up all the time, people would probably be like, okay. But if I say my Linux servers were up, driving a, you know, customer satisfaction rate of 98% because they never hit a blank page, that may sound better to them, right? Anyways, that doesn't matter. We're not doing any of that stuff right now. That's more over in like the course where we talk about interacting with the business and stuff. But let's check kernel package info, echo the number of kernel versions. All right. So let's go look at this, and some of these commands are similar to our other ones. We did a uname-a, and we see everything about the kernel. And then I say check for old versions of the kernel that are on the system. Now, in this system, we're on an Ubuntu system, and we're assuming that it's got a boot directory, and it does have boot. And then inside of there, it has the versions of the kernel that exists. Now, this version right here, VM Linux 6.8.0-51, is the same one that we see running on the system. So we could surmise that that was the one that was called to start the system. We could also prove that to ourselves with this. We could prove that to ourselves and go, oh yeah, that was the one that was called. Okay, so the boot image is right there. Okay, good. We know that. But then we might say, well, what the heck is this one then? This one's that's a link. I know that because of the color, but we'll prove that to ourselves in a second. And also, guys, just so you know, I often use what's called the Socratic method, and we actually have a whole. I need to re-record them because the video on them is terrible. But I have a whole section where all we do is the Socratic method to learn Linux. We ask ourselves questions, and then we go and verify that we know how to do these things. And again, it's not a challenge, but it's to see that we understand things. So I want to prove to myself what I know about this, that those are soft links. I only know that because of the color on them, and we don't always have the color in all versions of modern Linux. Those colors are aliased inside of our we've got an environmental variable for ls colors, which we can look at too. But what I can do is I can go look at that command and add a -L. I like to add the -L back here, but it doesn't really matter where you put it. And now I can see that right here, this L designates that this is actually a soft link somewhere else. And then over here, I actually see that that soft link is to the exact same location we're in, which is boot. VM Linux is actually linked over here. And then boot VM Linux is actually linked over to here. So, oh, I'm not in there. So in here, there is actually only one version of the kernel on this system. The other two are soft links back to it. It's like there's one that exists and the other two are soft links to it. So how many versions of the kernel are there? We're going to echo 1 into root kernel, because that will set that value to 1 so that when our lab checks and allows us to move forward, that's good. And we come down here and we say, now we have to check how many packages are on the system. So dpackage-l. So dpackage is the way in Ubuntu to look at your packages. And when you do the command by itself, I purposely didn't do it by itself, it's going to show us everything, and it's going to lock us, dpackage-l. It's going to lock us in a interactive window where we can go forward and backwards. One thing I like to show you guys here is you can go forward line by line with the enter key. So line, 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 line. Or you can go, like if I'm looking, like I know that I'm looking for something in the S's, right? I want something that's like SSH or SSL. I would hit spacebar to go page by page until I get down to the S's. And then I might, I blew by it. And then I come in here and I go, okay, here's my, maybe if I had something that was SSH or SSL related, right? They would be in here. And then, that's okay, but I can also search for things. It's much better to search for things. Don't manually go running up and down pages. And I can look for like SSH, and I would see everything in there that has the word SSH in it, either over in the actual package name, OpenSSH client. I wasn't going to find that down in the S's. OpenSSH SFTP server, SSH import ID, I would have found that, and SSFHS. Anyways, I've got them all here. So then that might help me to find another one that I really like is SSL. So like if the security team came and made sure they said, hey, there's been a vulnerability found in version 3.0.13 of OpenSSL. Can you tell me which of your servers has that on it? I could do that pretty quickly. And I would probably search like this, right? OpenSSL, and just find, and I might even try to break that down even more, but I might even do this. This is cheating, but something like this, so it only finds me. No, maybe that wouldn't work. Well, maybe I didn't find it as small as I wanted, but maybe, well, you could look for the individual packages too, but that's neither here nor there. My point in showing you that is I can go look and verify the versions. This is not as good as automating that. I can automate that type of report with Ansible later. We get into that later, but I can see in the system what's there is my point. I can get the data out. I can then analyze it or do whatever we want with it. But you never know like what kind of weird things are going to happen. You're going to get approached a lot in the Linux world and in the Linux admin and engineering world by your security team. They will almost always be bearing bad news, but they are a lot of times going to be the GRC team, the governance, risk, and compliance team. And what they want to know is, you and your team agreed to build servers to this standard. Can you prove that you've done that? Because all security, guys, just so you know, like all security validation and all security interaction that you're going to do as an engineer is going to be build something and then assert or prove that you did it. Those people, the GRC team, so if you're one of these people that wants to go do security, and you're going to probably find yourself checking a lot of boxes early on in your career. A lot of people I know hate security early on because you do so much box checking. But you're going to be going to people and saying, okay, we assert that this is true, prove it. And then you're going to have a third-party vendor come in and validate it, right? This is always the security process, is you self-test, then you assert, and then somebody comes in as a third party and validates it. That's the like PCI methodology. If you ever do payment card industry, you will always do your stuff and assert that we have done all the things we say. Then they come in and look at your documentation, pick it apart, find anything that's wrong, and then you typically have a certain amount of X months to fix it before they come and check again. And then that's typically your violation if you don't check it, or if you don't fix it by then, you'll get some kind of PCI. And you don't want PCI violations. They're big fines. And you say, well, I just won't follow PCI. It's not a government standard. You're right, it's not. But you won't be able to take credit cards, so that'll be the end of your organization. Because who's sending cash checks in or cashier checks in anymore, right? Nobody's doing that. All right, anyway, so I said, how many versions of the kernel are you on? Well, you're technically only ever on one kernel, but how many other versions do you have? Well, you only have the one because the other two point to it. We saw that. I said, how many versions of the kernel do you have, and why are the others not considered kernels? Because they're just links back to the kernel. So we saw that. And I said, approximately how many packages do you have on the system? That's this command here. Right here, word count dash L. Now, it's not exact. It's probably closer to like 810. And the reason is because there's a significant amount of headers at the beginning. We can do an NL and then more. And those first 5 lines are just BS. Those first 5 lines are BS. If you've never seen number line, I love number line. It will just count everything up for you. So at the bottom, I see that I'm at 815, which is the same thing as when I had done this, except one shows you all of the output still. You might say, well, why would you ever do this? I'll show you a fun one that I like to use. So let's say I was, this is a good reason to use number line. Let's say let's grep failed. Let's grep kernel from var log syslog, right? There's a bunch of kernel output. Bunch of kernel output been happening all over the place. Well, what if I nl kernel, or I just nl var log syslog, and then I'm going to grep out of that kernel. This is why this is important. Because maybe this Ubuntu kernel, maybe what I see in 900 here is the kernel. This is maybe something I've identified as the start of an incident or the start of a problem, but this is not in and of itself the actual problem. And maybe I know that the things that I want to search are just after this. So I might say, okay, well now 900, that's useful because then if I go into like view is just a read-only VI. So you can view a file and then jump down to 900 with like G900, and you'll be at the 900th line, and then you can read everything after. Now hold on, some of you are going to say, I know a slick way to do that with grep. I can just grep kernel, and I can do this. I can say -a, give me like the 5 lines after it. This is true. You can see the 5 lines after anything you grep, but you might end up with a lot of noise here, right? You might find a whole bunch of noise if you do it that way. That's very possible as well. And the point of searching, if you ever do have to search things manually, the point is to eliminate noise. So my point in saying all that is you can do a bunch of different stuff, and you can play with that. A capital A in a grep will give you all the lines after. So this is 5 lines after the thing that I found. And then B, a capital B, will give me the 5 lines before. So again, sometimes you know a very specific thing's going to happen in a log and you just want to see what's before it or just after it. A and B are kind of your friends in that space if you want that. Not really directly related to what we're doing, but I'm just trying to add more useful things as we kind of go through and do some Linux, right? What version of SSH client or server are you running on your system? Why might this be important to know? So I come back here and I say dpkg -l grep for SSH, and my SSH client is 1.9.6p1 and my server is 1.9.6p1. All right, so why might I want to know what versions there are? Well, the first one for this is that semantic versioning is kind of the language of engineering, like as far as we always keep track of the versions of things on our system. So why might I want to know that? Well, because I'm probably going to have to report that up to security, either through my own attestation or my own reports that I generate, or and those are typically a tool, a thing we call a SBOM, SBOM, Software Bill of Materials. Here's all the packages on my system. Or your security team is going to maybe automatically pull them with some type of tool they have. And then all of the versions and all of the things that end up being vulnerabilities here are reported from the industry based on the version as well. So if I went to the NIST standard, there's a NIST, that's National Institute of Standards and Technology, CVE, Common Vulnerabilities and Exposures, right? And I can go to this database and I can go check these things myself. However, do you really think, if you're like a sysadmin or a systems engineer, that you want to be in the business of one-offing all of your security stuff? No, you don't want to go build this stuff. So a lot of times there's tools that have already been built. Could you query this page via API calls yourself? 100%. But would you want to do that? I mean, it depends how hungry you are for data and how much you want to play with this stuff. Let's go general here. We should have, oh, sorry, we want developers because we want to pull it as an API call. So you can request an API key, but you only need an API key if you're going to go over a certain number of requests per minute. And I think the requests per minute that they give you for free are, I want to say it used to be like 10. Look, all these are public domain, right? They're reported constantly by different researchers and people around the industry. You can have an API key, but it says right here, if you don't want to use an API key and you want to do a generic call, here it is right here. NIST firewall rules put in place to prevent denial of service, can thwart the application. Without an API key, you can do 5 requests in a rolling 30-second window. So what does that mean? You shouldn't do a request more than every 6 seconds. Is that... Well, think about this for a second. I build servers to like statically sit out there for maybe weeks or months at a time before they get destroyed and built with other servers in place. Do you think I'm probably okay with 7 seconds instead of 6 seconds on my CVE checks? Yeah, I am. Right? But also, again, most companies don't have the size and the scale to do this type of polling and stuff themselves. But could you come in here? I was actually playing with this the other day in VS Code. If you have there's little plugins that are free, and they're free for up to like 3,000 calls a day. You could actually go in and just hashtag over and say, I want to do a NIST call against the API in this, and it'll, I don't know, Copilot or whatever that crap is out, a basic version of it working. And I was using it the other day, messing around with the USGS. So some of you guys know I mess with the US Geological Survey, and I pull earthquakes and stuff. And it wrote the same code that I wrote years ago, and did it all for me. And I was like, well, there goes my hobby, right? Like, but anyways, my point is, you could go build a business around just polling these and feeding these to businesses and helping them remediate stuff. That's a big security thing for companies. Anyways, how to keep up to date with them. Let's see, best practices. They tell you best practices if you're gonna do a poll. Most things are you're only going to get so many returns, so you don't want to do too many returns. So then maybe you have a start index and you keep reading all the different pages. Not more than every 7 seconds, though. Or I guess you could do 5 in a batch and then wait, right? Because that's what the thing actually said. All right, anyways, my point in showing you guys all this is like, that's a whole different discipline that we don't want to play in unless that's what you want to do. And I don't know, look, guys, I don't know what you want to do. I tell everybody, we've got this Discord, right? I'll link the Discord to you guys. It's got about 4,200 people in it now. Most people are either in the Linux space or want to get in the Linux space, right? That's kind of what we're doing. And there's a lot of stuff that's like Linux adjacent, though. Like I have people that hang out down there that are economists. We have some PhDs in econometrics, if you don't know that, down on our server. We have some people that are, I know people that are deep sysadmins down on our server. I got people that don't touch any sysadmin work but are just SREs and we got a lot of software engineers because Linux is like adjacent to all of these other things. So I tell you guys all the time, like if you're gonna hang out with us and like do stuff in the Discord, which again is all free, you don't have to want to be like one of these down in the weeds doing all this Linux crap. You could just Linux crap is like my whole career. You could do Linux for fun as a hobbyist and go do all these other things. So my point is like, you don't have to be stuck on these one things. Anyways, all right. Digging deeper. In the enterprise, you may find yourself having to put in tickets for hardware or software implementation with different vendors. The first question will always be asked, what are the OS kernel versions of the system? What are the software versions you're using? Understanding this will help you greatly supporting enterprise Linux. Yeah, so you're working for some company. You guys have support contracts out to Red Hat, and maybe you have a different version of an SSH client. You're using like a company like Tectia that provides a separate SSH client that is like a hardened version of SSH, and you've got support with both of these companies. And you go to put in a ticket because this server, well, this is an Ubuntu server, so that doesn't make sense. But let's say it's a RHEL box. And this version has something that's not happening properly when your users try to authenticate. Maybe they're getting some weird, Mac library problem and this and this, and you want to ask them to help you dig down into it. I'm going to tell you right now, any of their engineers that get that ticket, their ticket's typically going to get filtered through some kind of like low-level support first, and those people just ask if you read the docs, and you're like, I already read all the docs, I already read all the wikis, just send me up to an engineer. if you're not providing the version that you're on, they're really not going to be able to help you. Because almost always the first thing they ask is what's the version you're on of the OS and everything. Because guys, most of us like I've supported roles like this. I've never supported it from like a this type of standpoint, but I've supported my dev teams like this. I will stand up the exact same thing that you say, and I will try to recreate the error. Because there's two types of errors at the end of the day: the types that we can recreate, and the types that just make us scratch our heads because we can't figure out the conditions. Well, I can never reliably solve a problem that I can't reliably recreate. That's a truth of engineering, right? And so you've got to give them the version so that they can go stand up an old version of a server. Look, guys, we know that we're on the back end of the technology adoption curve a lot of times in companies. We're not like always pushing forward to the newest versions of an OS. That's silliness. Maybe there's some there's maybe like some cutting edge startups that try to do that, but for the most part, companies favor stability and they stay on the back end of the technology adoption curve. If you guys have never seen it, it's a very common curve to see. Technology adoption curve tends to look something like this, right? You might not be able to see this very well. Yeah, early adopters, early majority, late majority, and most companies like to sit back here in the stability. This could also be like the very stable, or sometimes they call this the risk averse companies, right? Risk averse, and you can go look at all this stuff. There's a whole study on that if you guys want to go that way. And I say go out and find your favorite search browser and take an internet safari to read what types of Linux kernels are available, which ones map to the common OSs you have used, and why might this be useful to you. Well, if I'm supporting, because I just got in this company and I find out that we're an Ubuntu shop, and I'm like, well, I probably should ask that in the interview because I don't know any Ubuntu. No, I'm just kidding. But maybe you've got that, and then you come over here and you name -r and see the kernel. Maybe you go read up a little bit about what's going on with that kernel. That's 6.8. I thought we were 6.9. We know that RHEL boxes are up on 6.12. So there are newer versions of the kernel out. Well, what are the advantages to go into those newer versions of the kernel? Dances with Dirt said a lot of Debian. I have not run into a lot of Debian in the enterprises that I've worked at. There may be Debian out there. I have not run into it, unfortunately. I've done probably, if I had to guess, somewhere around 90% of my career around RHEL, and then maybe 5% around SLES, which is SUSE Linux Enterprise Server. And then I'd say the last 5% probably fall into some of the weird stuff. I shouldn't call it weird stuff. Let's call it like the stuff that's so like off to the side that it's like specialized tools. And yes, I dropped Kali into that. I know Kali is like, that's Kali. I know that Kali is like the the standard for like security and stuff. Like I've been messing around with Kali since it was Wapix, guys. So like I know I'm pretty familiar with that tool, right? But even then, in the enterprise, I don't run into it at all, except for when I was running Red Team at AAA, and I would give it to my different engineers. I had Kali boxes stood up in the environment so that they could do their tests and stuff, but they could have their own desktops out in the environment that were unwipeable, and then they could pull all their notes off and stuff. All right, so that's checking kernel stuff. Let's go to our third lab, right? And for anybody that got here a little later, what we're doing is we're going through the labs that are free on Killer Coda. Labs that we've written as a group, the Professional Linux Users Group, and we are asking ourselves questions and figuring out what we can know about basic Linux, right? Like we're going over basic Linux. I'm talking about it as it kind of relates to the enterprise. Here is the lab. If anybody wants to do the lab with me, said I was just curious because Debian is notoriously slow to update, but RHEL makes a lot of sense. Yeah, I think Debian's a fine. Like I've run Debian. I think we even have some of it here in the home lab. Maybe I don't know if I have any of those boxes up still. Well, these are our virtual machines in the environment. No, I don't think we have any Debian going on right now. These are our different environments. I do have to finish standing up the werewolf targets probably today. Yeah, no, I don't see any Debian going on. We do have some older. Yeah. Don't see any of those. Those are just our virtual machines on our like lab infrastructure, right? All right, let's pull this up here real quick. So now we're going to do some lab disk stuff, right? So this is another, they all start the same. You're a new system admin at a company. You've been tasked with finding out information about a set of servers that has little or no documentation to it. This may be one of the most common things in all the world. Kara Jury said we switched from CentOS to Ubuntu like 3 years ago. Pretty smooth sailing. Nice, nice. Do you guys? I don't want to know the company or anything, but do you guys have like a canonical support? Do you guys actually have a support contract on that? Because I know a lot of times. I mean, if most of us that ran CentOS, because I've run companies with CentOS, we didn't have support. We just, our support was get it running again, right? And I imagine, yeah. So if you're not paying it, then Ubuntu is the same way. But here's the thing, guys. Like, I mean, unless you're, if you're in that back, like I was saying, if you're in that back, just like we run Linux to have stable platforms for our people, we're not pushing like the envelope of technology. It's perfectly acceptable to do that if you have a couple of Linux engineers that can keep stuff running, right? That's perfectly fine. Yeah, Dances with Dirt support contract is required for government stuff. Yeah, I have to be able to go over and wring somebody's neck about a problem. I have to, even though I'm a Linux engineer and I've been doing it a long time, I do not specialize in RHEL kernels in the way that like 150 people over at Red Hat are sitting there waiting. They're not waiting, they're probably doing other stuff, but waiting to take work and fix kernel stuff for certain versions of the kernel. Like I could, even if I was the smartest guy on planet Earth, I couldn't do that as much as all those smart guys doing as much as they could. So the reason I point that out is we specialize in kind of the things that we specialize in. And as Karjur said, like no support, but I can go out and read this stuff, and I can read the docs, and I can keep a thing working. Now, if I was pushing like all the future versions and all the new versions of things, and I was just like really trying to be like an early bleeding like red, bleeding red edge adopter of all technology, I would probably want some type of support and because you'd be sending in tickets daily on shit that you'd be doing. But most of our companies are very risk averse. They just want technology to work. I joke around all the time about how like I try to explain stuff to project managers and managers, and they're like, their eyes just glaze over and they just go like this. And then I joke around about how we're just casting spells because nobody knows what we do, but as long as it works, they don't care. And that's true of most organizations. They really just want to back up and not have to deal with any of that. Atticus said, hello, Scott. I hope you're having a good weekend. I find myself doing labs more as time goes by. Now, yes, command question I have a chance of answering. Nice. Yeah. So we're doing some stuff. We're going to check some physical disk stuff. We're going to check the number of disks that are on this box, and then we're going to echo that in a partition. So we can do fdisk-L by itself, and that's going to dump a good amount of information. Sometimes this just blows the screen up, but currently it's only doing one. And then maybe I can look for VD, which is that's the way that they do their virtual disks. So I see that we have VDA, that's the disk. VDA would be the first disk. If we had a second disk, it would be VDB, and so on until we got to Z. That would be the 26th disk. And then the 27th disk would be VDAA, and the 28th disk would be VDAB, and then it would count up again. And the furthest system I've ever maintained as far as like Linux that had disks local to it, I've been up in like I've been in at least like the H's, so like VDHZ or something like that, where I've had like hundreds of disks on the back end SAN. But here's the thing, it's funny, when your system first comes up, if it can see the disks, it'll enumerate them all, but you don't want it scanning those disks, so that's why we put that fast boot in the the kernel command line. And then once it comes up, we let multipath choose the paths so that we only take the disks that we want, right? And this is a probably less of a thing now because we're probably sharing stuff up and carving it better. But back in the day, we used to see all the disks on the SAN, and then we would only use the ones that we were supposed to. But or we would only mount up the RAIDs that we were supposed to have based on the multipath, right? But okay, I can see that I have one disk, and then I have four partitions: VDA1, VDA14, VDA15, and VDA16. Now, we are not going to go too much into the partitions, but typically you can have 4 primary partitions, but you can take that last primary partition and turn that into extended partitions, and then you can have 127 more extended partitions off of that last one. So then you could have a total of like 130 partitions on a disk. But only the 3 can be primary, and then the 4th one becomes an extended one, and it can be like I think like 1 through 127 or something like that. But you lose that 4th primary disk when you make it extended, right? Don't care about that too much right now. We can just see what's on this system. And then why did we use VD? Like, why did I say that? And that's funny. I don't remember capitalizing that, but I feel like that got changed in a pull request that I didn't catch or something. But why did we use VD? Well, because that's the name of the virtual disks. On most systems, you would use, back in the day, was HD. Now it tends to be like SD. If it's like a Zen environment or Oracle, sometimes can be like XV. XV would be the Zen disks. In my home lab, that's what we tend to see, right? Go jump into one of our home lab boxes. Right? Yeah. Oh, somebody was carving these up. But XVDA and XVDC. So I have different disks on there. Right? Different disks here. And people have carved those up to be whatever the different names and stuff that they wanted. All right, so over here we can do an LSBLK, block ID. Those are my 2 favorite commands for this kind of stuff. And then we can also answer how many disks are there. There's 1 disk, VDA, and he has 4 partitions on him right there. Boom. So now we've seen that, and I said, of these disk commands, which of them seem to show you the most important information and why? Well, they're all giving us good information. I like LSBLK because it shows me the attached disks. And by the way, often I hear, when we talk about this, often people will tell me, I say, what's all the disks that are in your system? And they'll say DF-H. DF-H is not accurate because it will show me mounted file system information. If I've got a physical server out there, right? Well, I guess if I have a virtual machine too and it hasn't been mounted yet, but I got a physical machine out there and we just added a bunch of disks to it and I'm doing DF-H and I'm like, why don't I see these disks? Well, why would you see the disks? They're not mounted. They're just inert sitting there in the system. You will see them if they've been if they've been found on the bus, you will see them with LSBLK. Yeah. That's actually interesting. There's a nice little way of seeing other information here. You can use T, and there's also another one I think that we used, which was like dash. Is it dash F? Yeah, that's the one that shows you. Remember we said earlier, I wasn't really trying to trick anybody. I was like, you can cat /etc tab, and then you can say, well, root right here, and actually cat proc cmd line. Here is the boot image for my system, and then here is how root knew to switch to the root of the file system. This is like a switch root that happens. Well, in /etc tab, that cloud img root fs, that same one that's called right here, is also mounted. So that's what's mounted there. And if I did a df-h, that's what's being used as a backend. Right? The root is dev VDA1, but where do I have a mapping of that? Here I see that I was going to call that, and here I see that that's the label. But the different way, a nice way to find the label is just look right here. There's a label. VDA1 is that label cloud img root fs. The only other way I know how to find that, guys, is go down into dev disk by label and do an ls-l to see that cloud img root fs is VDA1. That's the only other way I've ever known to do that. But look, LSBLK will show me right there. So I can see how my root file system maps between dev VDA1, even though the /etc tab, which is the mapping that my system called when it came up, doesn't map to dev VDA1. It maps to the label cloud img root fs. And there's like 4 different ways that I know how to map out of an /etc tab. And you might say, well, what's the right way, Scott? Well, first, here they are. You can do by label, by part UUID, by UUID, and you can do it by path. I don't think I've ever seen it by path, but yeah, you can do by label, by part UUID, by UUID, or typically by the name, the exact dev VDA1 or whatever. I have seen all kinds of different Linux systems use all kinds of different ones. Currently, Ubuntu seems to favor the label, right? They're using the label here. But in RHEL systems, often I see by UUID, right? Like UUID is always going to be the one that we're going to use, and it's always going to be the same, and that's what we're going to do. So that's kind of the way you can do it. Hey Zeddy, over on the Twitch side, how's it going? We are just going through labs right now and kind of asking ourselves some questions and seeing if we can figure stuff out kind of as we go. So down here we looked at some stuff and we can move forward in the lab. And I say check the file system type and mount points for this system. So echo the file system type into the root partition and echo the name of the file that defines all the mount points. So how do we find the file system types and mount points? Well, we can type in df-h and see what's mounted. But we also might want to type mount and grep for maybe like VDA. And this will show me all of the VDA disks that are mounted. And I'll see the file system type. So this is an ext4 type file system. That's a journaled type file system. ext3 and 4 are both journaled. You won't see a lot of ext3 anymore. Most of you in your career nowadays, if I had to guess, will see a lot of ext4 and a lot of xfs. Those are the two kind of common ones right now. You may see some ButterFS, which is BTRFS. They do call it ButterFS, but it's BTRFS. And then, you know, I hear a lot of people talking about ZFS coming. I haven't seen ZFS in the enterprise. I used to use that with Solaris back in the day, but you can go look at all the arguments over the years with if it's ever going to get integrated fully into the Linux kernel, and there's all kinds of stuff up and down, people arguing and stuff like that. Phi Linux, I've never seen ZFS in the enterprise in Linux. I've seen it back when we ran Solaris everywhere. Yeah, ZFS was great, but I haven't seen it out in the world too much. Zeddy said, thinking of converting all your office interns to Linux. W11 on Indy has taken a bunch of, oh yeah, Windows 11. Man, we just had Windows 11 at the school district that my wife works at. They just did it this last summer. They moved over to Windows 11, and all the students' laptops are brand new, and they're all freezing up. I have a laptop over here from work that they sent me. I literally can't do anything on it. It doesn't. I literally, like, I go into it and it's all. Log into it. It's funny. I'm not working today, but the thing literally can't do, like, I can't open VS Code on it if I want to. I mean, I mostly do everything out of a terminal shell anyway, so that's fine. But like, the thing, I have a Slack. I actually have the Slack app, and it freezes up when I try to do searches in Slack. It's ridiculous. Okay. Software you need runs on Docker, but needs 5 gigs of RAM. Yeah, that's. Yep, good stuff. Oh, actually, I was thinking about something. I got asked to go speak. So, speaking of the school district, I work with WestMech out here in Phoenix, and WestMech is this group. It's all like cybersecurity kids, and like they go to like it's almost like a magnet school for all the cybersecurity. And one of my buddies runs that program, so I go out and speak to his kids every year and when they're doing Linux. But the local school, like the high schools, have asked me to come talk to the software engineering kids, which is funny because like they always want me to talk to like the software, like the programmers, but that's not really what we do in Linux. It's almost like we don't do that here. We're like software engineering adjacent. We support the software engineers often, and we do stuff that looks like code sometimes, but we're not packaging up my work artifacts. The things that I produce are not software code that's run by applications and stuff. I build servers, right? My work artifacts are the Ansible code that I write that configures those servers and runs in a CI/CD pipeline, and then also the server itself, right? Those are the things that I do. So those are my thoughts on that. What are the types of names that are given to the partition? Again, they're numbered after. So the disk has a VD lettering. There's a letter assignment based on its position, right? Its ordinal or counting is counted based on A, B, C, D. And then the partitions are not counted in normal number, right? They're not in normal number order, but they are numerical, so 1, 15, 16, and then we have one that's not mounted. We saw 4 partitions, but we see one that's not mounted. So why is that one not mounted? We can go try to figure that out. And then I said, what is the file system of the partitions? So the root partition here is ext4, right? Got ext4. I say, why is it important to know the size of the partition as well as the inode count? So that comes up here in a second. We did all of these things, block ID, so we can look at what's going on. We can throw that into the file so that we can move forward in the lab. We can look at etcfs tab and see how these things were mounted, and then we can go look at the files. We can look at all the different types. It's actually funny, there's one missing here now, I think. Yeah, dev disk by sequence, I'm not even really familiar with that. All these other ones are just sitting there. And then we can throw etcfs tab in there, and then we hit check and we move forward. And right here on this one, this is the size and the usage of the disk. So this actually starts to be kind of useful for people who maybe you're getting trouble tickets that say, hey, certain things are not working in our environment, or we don't have enough space, or we're doing something. And quotas aside, quotas are a different topic, and not all file systems even enforce quotas, so we're not even talking about that. Let's just look at the space that we have. If I do a df-h by itself, it tells me everything. Real quick, if I do a df by itself, the reason I've never shown anybody df by itself except to show this one thing, that's next to useless. I mean, I've lived in a terminal for the better part of 25 years, and I don't know a single thing about that without like counting on my fingers and trying to figure it out. I'm a big fan of df-h. Shows us what we need to see. We can see the size of the file system, how much is used, how much is available, and a percentage. So we are not using too much of this. We have 14 gigs available. That's gigabytes, by the way. And over here then, we can look at just the, we can look at df-h on slash. So we just look at the root of the file system. And then what we did was we looked for size. So we only, and we removed size here. So we removed this line here. And then we did the second one. So we printed out the second one, which was 19 gigs, just to get the size. So if I want to see what that value is, it would be 19 gigs right there. So the size of this is 19 gigs before we had a little bit used. So we come down here and we could just make a big file if we wanted to. We could say dd, and we can say infile equals dev0. So just a big file with a bunch of zeros in it. And we can say outfile is equal to, and then just here big file. Let's call it big file. And the block size is equal to 1024K. And the count is equal to 3,000, right? So that will be 3,000 1 meg blocks written into a big file that just grabs a bunch of zeros off of the processor. And if I do that right there, and then we do our df-h against just root again, we will find that now we only have 11 gigs available. We've used 3 of those gigs. And now we're at 42% usage instead of 26. We could keep doing that if we wanted to. We could also go look at, oh, I didn't do it in root, whatever. Make sure you do it the way you're supposed to. I didn't hit the command, so I didn't do it the same way. But anyways, if we look at it here, then you would see that it's 3 gigs. Now, the storage, like the space of our file system is one thing that can fill up. Something that you guys might never run into in your careers, and hopefully you don't, but if you work in big file systems, you will run into inode usage problems. Inodes are the number of addressable memory locations we have out in that storage. And the places that I've been that have had inodes fill up are like when I worked at Keras, where we had like cancer research. And in that cancer research, there would be a lot of little tiny JPEG files. So in any one like run of the way that like the BioPython would run and the different applications that we had underneath that, they would be writing all of these tiny little JPEG files. It's just tiny little files, almost no space, but they would just be writing like millions of them. I don't know why they were doing it. I wasn't part of that pipelining, but on the underside of it, on the sitting here, we were using up massive amounts of inodes. And we actually ran out of inodes a couple times on the GPFS file system. So we set up a monitor to track them, and then we would keep updating them as we needed. And there's like a trade-off with space versus what's out there. But The way I always liken it is if you're thinking of it like a library, because storage systems really are like a library. When you first come in and you have like a card catalog up front, all the places that can address books out on the shelves, that's your inode space. How much space can you address? And when you run out of places to address space from, then you can't put any more. You could put anything else you wanted to out on the shelves, but it wouldn't matter because you wouldn't be able to find it ever again. It would just be lost off in space. So the shelf space is like your actual size of your file system, and your inode count is your ability to address and find them later. Yeah. Okay. So then you look up, so this is one thing that I say you can do. If you look up the CIS benchmarks for RHEL 8, you'll notice that one of the first tasks is hardening a system set up with different partitions. Why might partitioning a system be so important to security in general? And why might you not want to partition a system like that in the industry? So sometimes we don't partition things for a reason. Sometimes we have a good reason not to partition things. Sometimes we have to partition things. And one of the things that I would tell you, especially in our little security engineering courses, we look at the STIG benchmarks, but the STIG benchmarks have the same thing. You got to partition all this stuff up. Well, what if it's just an ephemeral stateless node and nothing on it ever matters? Do I still care then that I have partitions? Does it really matter? Or, you know, if I actually have the data being sent off in real time, and you know maybe the processes that are churning on that box are not so important because they can just go down, come back up, and be reconnected to their network shares, do I still have to partition the disk? Why or why not, right? And these are the things that we have to be able to kind of understand and answer. Atticus said inodes are Dewey system. Yeah, if you want to think of like the Dewey Decimal System, where you only, because if you could run out of the Dewey Decimal System in a library and not have anywhere else to address books with, wouldn't you not be able to take the next book in even if you had plenty of storage space? Yeah, because then you wouldn't be able to do that. So Dracnet said, why some hosting companies give you plenty of HD space but limited in inodes in a way that you'll never use the full space. I've never seen that, but I don't doubt that that's true. Use things like, well, okay, then there's also, by the way, so Dracnet, there's another thing that comes into here. There's 3 typical ways that we attach storage to boxes, especially out in the cloud. This becomes very prevalent in the cloud because they're your only 3 options. But for us in the like systems world, we have typically like a network file share. So NFS, network file shares, are we just mount the file system and then we can do whatever we want with it within our permissions, right? That's NFS. Then there's block storage. Block storage is attached, sometimes over a network, but still attached, and the network protocols for that are like iSCSI, or you can just attach things like up in the cloud. And you attach a block disk, and then your system reads and writes blocks to that disk based on whatever file system and partitions and stuff you put on it. And then the third one, like the one that's like, I really want to say is the way that like big data does a lot of this, is object storage. Object storage is you make API calls and get data back from the different locations. So you make an API call into like an S3 bucket, you get back the data in a like unstructured blob format, and then you put it together on your own system. And there's some really fast object storage type solutions out there. Ceph storage is a big one. Ceph storage is popular because it does that, and it can also still do block, right? Whereas you don't necessarily attach those things and then like NFS mount, and I don't think Cephs can do NFS. Anyway, so my point is there's like those 3 big ways that we attach things, but I haven't necessarily seen them limit inodes like that. Most of them, they'll let you stuff as much as you want in there, and then they'll just charge you for it. Atticus said having a predetermined partition for specific tasks simply sounds like a good housekeeping. Yeah, Atticus, like, it really depends, like, on what you're doing with the systems, for sure. Yeah, I mean, it depends. Yeah, I try to be a good classroom if I can for you guys to see this stuff and play with it. And obviously in like some of the cloud ways, there's different ways that different vendors do stuff, so I don't know all of them. I can speak the most to AWS because I definitely have the most AWS certs of all my certs. And I'm technically Solutions Architect Pro with them, so I mean, I guess I can answer some things. And I know how to go reference stuff and look it up if I need to, but I definitely have never seen the inode thing with them. All right. So anyway, so that's pretty much that whole lab. Lab 3 was short. Let's go lab 4. This is one of my favorite ones. I mean, I like all the labs, but lab 4 is pretty good. I'll give you guys a link. These are free on the Killer Coda site, so they don't charge you nothing. Let me go here and over here for you guys. So, oh, and we're at 2 hours. Jeez. Let's take a quick break because I'm at 2 hours. So let's go take a quick break and say, I'll put my little hourglass up. Where's it at? Where is my hourglass? Give me 1 second. And I'll say quick break, then more. And the break will be 8 minutes. All right, I'll be back. You guys can hang out, get in the lab, get in the systems. We'll go back to doing more Linux here in a minute. Fi Linux said he likes Sumatra. I like this tool. I think it's great for PDFs. This PDF actually reads in light mode, and I just went in the Sumatra configs and inverted it to dark mode. So like if you ever look at the book, which our Prologue book is up on, it's up on LeanPub. Like if you go look at it, it looks like crap right here, because that's not how it's a white mode book. This is all blue, but it's inverted. The color scheme's inverted. So, but I like it for reading stuff. This is the book. We'll do lab 4 next, right? I'm gonna give it 2 more minutes. Drink my drink here. If you guys have any questions or want to talk about the Linux group, let me know. It's here to help you guys get better at doing this stuff and try to get into doing this stuff professionally, if that's kind of one of your goals, right? Everybody's got different goals, but yeah. No, Atticus, I just did 8 minutes. So 2 minutes left. 2 minutes left. Dances with Dirt said, how long have I been doing this, teaching things this way? I've had the professional, so I've been teaching, let me back up. I've been an engineer for 23 years now. I've been a college professor for 17 years. I started running the Linux users group, the professional Linux users group, so 11 years ago. I started that. And that used to just be me and my buddies hanging out at my house, eating pizza on Saturday nights and doing Linux. And then about 6 years ago, we got on Discord. And honestly, it was less than 100 of us sitting in Discord until like 2021. And then I just started streaming it. I was like, screw it, we'll just do this stuff. We'll stream, we'll hang out, we'll have fun. And if people want to come and hang out with us, they will. And sometime last year, we were almost at 1,000. We just barely hit 1,000 people. And then we kind of like picked up a little bit on the YouTube side. Like, I don't know, somebody liked one of my videos or something. It went to like 200,000 views. And then we just kind of, I wouldn't say blew up, but we went from like 1,000 to like, we're at 4,200 now. But I think we still have a pretty good little, like, I don't know, almost like a down to earth little group of people that are in there hanging out and stuff. So yeah, it's fine. You know, it's a good group. It's people who hopefully want to do this stuff professionally. The goal isn't like to make this the Scott show. That was never the point. The point is to like have a group where people can hang out and work on this stuff. And I haven't even looked in Discord too much today, but there's some traffic going on down there. People talking about stuff. Get this out of the way. Be done with our break. But we do have, we have all kinds of events always coming up. Like there's a writer's room today. If you guys don't know what the writer's room is, that's for the guys that want to work on these books. These books are free right here. So the Linux admin course, completely free book that the guys put together from the course. If anybody wants that, there's the book. You can actually literally just print this book off as a PDF if you wanted to, right? You can look at it in a bunch of different modes. And then the security engineering book is right here. And this is the book. And the guys put this all together. This is all up in GitHub. You could go grab the pieces of the book. They make it. They have like a markdown docs tool that just like turns it all into a book and just shares it out right from GitHub. That's pretty cool little things. And then again, you guys could have your own little versions of that. Those are free books out there. And those courses are run for free in the Discord. The next group of those courses are coming up in September. So September 20th. And there's like discussion posts and people tend to, it either resonates with you or it shuts you off to doing this stuff because you're like, I hate all this stuff. Well, not everybody wants to do this stuff professionally. That's for damn sure. But anyways, there's a bunch of stuff going on there. All right, let's get to the labs. You're new sysadmin at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation on it. Well, that's pretty common. Let's move this up just a little bit so then you guys can see your chat there. All right. Let's check our network information. Let's put the name of my network interface into a file called root interface. Let's put the IP address of my network. So if I knew nothing about these servers, I was just connecting to them maybe via host name from some DNS that's maybe even run by one of the Windows guys in our company. And I go, oh, I need to figure out how my servers all work. I need to get in there and connect to them and stuff. Let's say I'm just sitting here. Oh, I got asked a question about my hypervisor. I run a tool called XCPNG. I don't necessarily recommend it for people that are like getting into newer, you know, if you're going to do like home lab build outs. I don't often recommend people do XCPNG because it's kind of an older technology. It's the fork when Zen got bought by Oracle. So when Zen went over to Oracle, XCPNG forked. And it's a great tool, but I tell people, if you're going to spend time building stuff in the home lab, this is my advice right now. I sometimes give advice, sometimes I don't. I do give the advice, go build it with Proxmox. The reason I say that is because you guys seen how much like VMware has been bleeding the last few years. They got bought by Broadcom, and they like went 4 to 10 times as expensive for all their licensing, and people like are jumping ship in waves. And one of the big ones I read that got a huge amount of bump is Proxmox. So Proxmox also supports Terraform. There is a Terraform provider for Proxmox that I know people use, and I know people down in our Discord use it. So, but yeah, I have a whole bunch of servers. There's all kinds of architecture out there you guys can see on my home lab up in the Discord and stuff. We talk about it pretty regularly. In fact, there's a whole channel for it. With sometimes people ask. I'll show you guys real quick before we get back into the labs. Here's our lab environment. You can drop your public keys, only ever public keys. Never give me your private keys. And you can drop your public keys in here, and then you can connect into the home lab too. So we've got the ProLug and the ProLug in either one of the users that you jump in on. Well, it's all ProLug now, so that's why I modified this dock. You come in, you get dropped into a little Bastion host, you get jailed as a user, and then you get sent over to our admin labs or our security labs back in our base lab capacity, and you get jumped into your own server. You're the only one in there, and you do all your stuff in there and whatever. Yeah. I've been building this stuff out for a long time, so that's all up in the Discord too. So let's see. So you're a new administrator at a company. Check network information. Put the name of your network interface into a file. We could do all this stuff. So here's IP adder, and IP adder is short for IP address, and it gives us the information about this box. As there's a loopback address, there's an ENP1S01, and a Docker 0. Now, I'm going to just say real quick, guys, I hate to... If I was going to pull this up on a screen for actual, like, users, or, like, I was in a meeting and somebody said, hey, can you just show me the IP address of that machine real quick? I think that's too busy. I think this is too messy to go find this. What I prefer is this, IP-BR-ADDR. That's what I prefer. It's just a nice little concise... This is what our lab... That's what our system looks like, right? Well, hold on. We got S-Wine. Do you have a recommendation for building a lab as hardware? Like what price range? S-Wine, it really depends what you want to do. In my home lab, I just kind of play around with tools and stuff. Like, I just play around with monitoring and system stuff. So I have my monitoring of my different stuff going on. These are all the people that have tried to log in and failed in the last 6 hours, right? These are all the people they get banned out with fail to ban and that kind of stuff. And then like these are my server uptimes. What I would tell you is it really depends what you're looking for. There's a pretty good set of like used hardware suppliers on like Amazon. You can get a pretty decent little server for about $200 if you want to go that route. And this was for the question S1 asked, do I have a recommendation for building a lab? What I might tell you is before you go do any of that, I might say, well, do you know that you guys can go and run stuff up in the cloud? You can go get an AWS account. Yeah, you got to put a credit card on there. That's okay. But if you just run your 750 hours free per month of an EC2 instance, you can get a whole lot of Linux into that. But you can't. You wouldn't get a lot of other practice in there. But there's all kinds of other things you can practice with and mess with. The other thing I tell people is well before maybe you build out a lab. Now, you're probably asking because you're already doing Linux, and that's fine. But I would tell people, like, let's say it was somebody's first time hands-on on Linux. Well before I ever told them to touch any Linux and spend any money on it, I would tell them to go spend time in Killer Coda. And these are all these different topics right here that people will teach you for free. Like, if you were going to tell me, hey, Scott, I'm going to go spend a whole bunch of time in Ansible, But then I say, well, why don't you go spend some time? This guy Scott, whoever the Scott guy is, he put together all this Ansible stuff already for you, right? And here's this Scott guy's Ansible course, free. And you can maybe go look at it and go, oh, what is that? I don't want to do that. That looks like shit. Well, that's way more free than spending a bunch of time building a lab, right? This is what I always tell people. I have college students, guys. I teach 400 level college classes, right? I teach all bachelor's degree. And I have students coming at 300 and 400 level going, hey, when do I stop doing like this, like command line stuff and go move into this, when do I stop in like the networking and I'm like, this is the job, man. Like, you spent a lot of money to find out that this is something you hate. I would rather be told right now for free on this channel, if you don't like this shit, go do anything else with your life. Anyways, I'm not saying you, and I'm just saying in general. Like, I tell my college students, like, man, that's an expensive fucking mistake to make it 4 years of your life and a whole bunch of money to find out that you're doing shit that you hate. I'd rather go find out for free on the internet, right? But that's me. And I have told college students that before. In fact, I've only ever had one college student ever that I've legitimately told them, I'm like, this is not for you. Everybody else I think could do this. But I had one college student that they just didn't want to do it, and they just couldn't, and they were just general shitbag. And I was like, you can't do this. Like, you need to go do something else. You hate it. You complain about it all the time. If you worked for me, I'd have fired you. I've told you guys I can't be a manager because I'd fire everybody anyways. But that's neither here nor there. Burn a live CD or try VM. Yeah, I tell people when I started in Linux, they used to just throw you a CD, or they tell you to go burn it yourself. And if you couldn't have Linux running, you just couldn't be a Linux guy. And that's not really true anymore. We can get you in shells and we can teach you a lot of stuff well before we ever make you install it, right? The installation used to be the part that was like the gatekeeping for people. In fact, by the way, if you ever go look at like the history of Linux users group, LUGs, they used to have meetings just to get Linux installed for people. That's what Linux users groups did when I was in college. They would call a LUG together, get a group, and then teach people how to install Linux. All right, anyway, so we support this. We make this stuff work. All right, so now I say, what's the name of your interface? So instead of doing IP adder, we do a whole bunch of piped commands. And did somebody do this? Yeah, somebody changed this up a little bit, but let's look at the command. So we did IP adder. One of my favorite things to do, if you look at a big long command output like this, is to strip back all the pieces. Because what's happening here, for people that aren't super familiar, we are sending a command into standard input on a terminal. The terminal has two ways to respond to us. It can send back standard output, that's the one, and the other is it can send back standard error. So IP adder by itself gives us no error. It just comes back with the output of the system. But if I did IP adder that, it would give us an error. You're a dum-dum. You don't know what you're doing. Oh, I know. Right? Like that kind of stuff. But I come here, and now I can catch the output before it comes to the screen. This was going to come standard input to the terminal, standard output out. I can catch that standard output before it comes to me, and I can look for something. In this, I can do whatever I want to. I feed it into the input of the next command. And in this case, I'm going to search. Search is, that's the GNU, I think it's regular expression processor, but somebody would probably correct me. I probably have that wrong. We could read the man pages on and figure out. But it's searching things, right? And it's typically doing it by column. And then we're looking for ENP. So what we're doing is we're taking all this output right here, right in here, and we're looking for ENP. So let's grep. -I will ignore case, but we just say ENP as it did. And now here's our ENP on two different lines, right? So then if we add more to it, then we can grep for MTU, which is maximum transmission unit, which is going to filter our line down even more. Okay. And then we can add, what do we do? What do we do? Add an awk? Oh my gosh. So then we added an awk, and in awk, we printed $2. What do you need, wifey?
I was looking for some papers.
Oh, okay. She's looking for papers. All right. So then we do this. And what did that do? That took this line right here, and awk is going to filter on columns. Awk wants to deal with columns. You can do other things with it, but by default, The default delimiter of awk is a space, but we can change that behavior with a dash capital F, and we can change the way that awk filters stuff down. I'll show you that here in a second, just to kind of show you a little bit with awk. But now that we did that, then we added this sed on there. This is just way more than we needed. And we did a substitute this for nothing, right? So substitute the that's so silly. I mean, it's fine, but whatever. Jeez, did this lock? Yeah, there. And what that'll do is it'll substitute anything that it finds on the first line. We didn't do global, and it'll replace the colon that's found with nothing. You can substitute any number of things in there. I could substitute ENP for sandwich. And it would put sandwich in there instead of ENP, and it would completely mess up my output. But it's something that I can do. Let me show you guys one real quick thing about awk that I like, and this is probably one of the things that I think is most useful about it, is let's say I just did like a head on Etsy pass WD. This is our pass WD file. There's 7 fields across based on the field delimiter of colon. Well, I can head Etsy pass WD, or I can cat it all, right? So let's just cat the whole thing, Etsy pass WD. It'll dump the whole thing to the screen. And then I could say, but I want to take that output and I want to awk, right? And I will, in here, print only $1, which will be this first field as delimited. Whoops, not until you do this. Right, so now the field delimiter is colon. And then we'll say print the first one, and let's just say the last one. So $7. $7 is defined as the last one from the data format, but it's not really the last one if the data were out of format, but that's fine. And then we'll do that. So now we got just that first field and that last field from that file. The reason I show you this, and the real correct way to get the last one if we didn't know that it was always 7 fields, is the number of fields. That's gonna, in this case, be the same net. Those are the exact same output. But in other data, it's not always going to be the same output because sometimes there's a different number of columns. NF is just the number of fields, so it always gives you the last column for any one line. All right, that's neither here nor there. That's not that important. Let's go look at, let's see, did we throw that in a file or something? Yeah, so we throw that in a file. So now we've got that value that we just had thrown into a file. And this is another one of those kind of important things to know, is this is a redirect. So something that was going to come to the screen gets caught by a greater than sign. Greater than sign is this guy, right? Let's see, for you guys, am I backwards? I think I'm backwards. So that's a greater than sign because it's this is greater than that. And then less than is the other sign. But greater than sign catches the output that was going to come to the standard out and instead throws it into a file. And if I keep doing that over and over again, and then I cat root interface, you will see that each time I did it, I clobbered the data that were there. And this is how you could prove that, because we can also append every time with 2 greater than signs. And this will be now 4 of them in there. But if I go back to this one, I clobber the data, meaning it's all gone. I wrote over the top of it, and it's back to only 1. So you can redirect with a overwrite of whatever's there. Sometimes we love to call that a clobber. Just go over the top of it. Or you can keep doing greater than signs and keep appending over the data that's there. Aho, Weinberger, and Kernel. I did not know that. That's awesome, though. I thought awk was just... Yeah, that's awesome. I didn't know that that was the name of it. Is there any info in the... And by the way, guys, I should point this out. I use awk as like a little, you know, bastardized program underneath bash to like just filter my columns, but it is its own complete. It's a full programming processing language. I don't use it like that though. I do have a couple of logic things that I can do, but I don't really use it like that at all. Awk and sed though have books written on them. They're very powerful. They will make you I think they will make you very useful at the command line, and they will help you a lot, and they will definitely make you more proficient overall in your job to know them. I tend to know my tools, and then like I just use them in the specific ways that I use them to find what I need, and then I kind of just spackle information on there. So I know awk, like I know like maybe 30 things I do with awk, but I'm not like some awk expert, right? Same thing with sed. I can use sed to like replace instances of things in a file. That's pretty much what I use it for. I claim no other like great expertise in that space, but anyway, so we come back over here and maybe we look at the IP address of our interface, and that's correct. That's the correct IP address, but it's that same thing. We took IP adder, that huge output, we filtered it down by looking for ENP and then INET, and then we just printed out just 2, and we got that value. We could also do that a little different. We can say IP-BR ADDR, and we could probably shorten this down like this. We could then take that and grep maybe ENP, and then maybe awk dash print $3. So we could probably do that a little more efficiently if we wanted to, but I'll tell you guys, at the end of the day, it's just looking at your mappings of things and looking at how you want to catch the output and change it for the different inputs. That's all you're doing. That's none of this stuff is ever, well, there's certain things that get more complex, I guess, but I don't think any of this stuff is ever harder than like chutes and ladders. Something points at something else, teaches us something else. All right, and then put that value in a file, sure. And then IP route, or I also like route. It's different ways to look at the same general information. So IP route or route, both of those are pretty good. And then I say, what is the default route of your system? And here's a way to look at that and throw that in a file. Default route is right here or right here. All right, let's look at that here so I can break that down. But let's real quick ping and see if we can ping our default route 3 times. Okay. So over here we have some questions. What are the home addresses of the IPv4 and IPv6 networks? So let's clear this up and let's just go look at what are the home networks of the IPv4 and IPv6. So loopback tells us home. Loopback always points to home. And home for an IPv4 network in TCP/IP is always 127.0.0.1. So some of you guys have seen those little nerd shirts that say there's no place like 127.0.0.1. They're saying there's no place like home. And that's it right there. That is the standard definition for loopback on all things. We can test with a MAC address, we can test the MAC hardware by hitting our loopback and make sure that everything is working in the TCP stack all the way to our MAC on our system with a loopback address. It allows for functionality testing without sending across a line, right? That's what it does. That's what we, on the networking side, that's what we use it for. The IPv6 home address is ::1/128. So ::1/128. That's the IPv6 version. It's funny how it said that. That's not correct down there, but my closed captioning is never correct. So I say, what does the pipe character? That's this here. So maybe we echo. This is BS, right? And then I pipe that to, I don't know, maybe we pipe that to, what is that? I think it's like tr, what is that? What is that tr command? I think it's tr upper. Is that right? What is that? Let's see. I have that somewhere in my notes. I always forget how to do that, but I could translate that to, it's this. It's this, but I don't think I have tr right. What's that command? Is that? I don't know, I haven't used this in a while. Should just be able to tr upper, right? I haven't used it in a while. I don't remember. What am I missing over there on the Ukalaka said I'm fresher trying to get into Linux. What else is required to get a job? I have a lot of stuff on getting the job over on the YouTube side, we had a question about getting the job. I have a lot of other stuff on getting the job. Depends the job you want, but if you're looking for like Linux admin, we do have a course on Linux admin that's free. You just go work through the course. If you're talking about getting into like building stuff, we have a security engineering course, which I think is pretty good too. This one's starting back up again in September, so in like 2 weeks, this one's starting up again. Free. The courses are free. They're just the cost of your time, about 8 to 10 hours a week of working through this stuff, right? Those are all run through the Discord. Where's my damn... Hold on. I know I have this somewhere. Let's just do TR to upper. I always forget how to do this. Get out of there. TR lower upper? Is that it? That might be it. Hold on. Wrong one. Alright. Yeah, I haven't done this in a while. Is that right? I don't know. I haven't used this tool in a long time. He also said things. Where's TR? Ah, that was my problem. There you go. Yeah, and then you could do it the other way, which is lower to upper, which is what I really wanted. And this is, look guys, I'm not telling you to use any of these to for sure I wouldn't tell you to use this to sanitize your data in any way. There's way better things to do for sanitizing data. Sending guy here, he's one of our mods. He streams, so you guys should check him out. I'm going through labs. We use Sunday mornings are for labs, and we're going specifically through the lab book. And what we were on right now was the kind of finding network information out, right? Like you do IP br addr. It's one of my favorite commands because IP adder just dumps way too much crap to the screen. So IP br addr is like a nice little concise version of what I want to see. And then we were talking about the pipe character, and I was just saying how you can pipe through something. So what was gonna come to the screen right here could then be captured, and we could send it somewhere else. And then I was fumbling around with this because I haven't used this tool in a long time. And you can go upper to lower, right? And you could, again, I wouldn't use this to sanitize my data in any ways, but you could make things upper or lower, and you can kind of modify this stuff around. Yukalaka is asking, hold on one second here. Here are the, so here's the courses. They're not PDFs, they're HTML, but you could print them to PDFs, right? You can print these. Here's the Linux admin course for people that need it. That's the Linux admin course. Plus, they're up in the Discord, right? That's the main place people. And then the security engineering course is starting again in later September for people that want to do that with us. All right. So that answers that question, I hope. So we come over here, and again, there's just a bunch of commands in here and things that you do. And then you pinged your default gateway when you got to the bottom of doing IPR or IP route, as it's actually written out, or route, and you saw the way that we found the different networks, right? So then we were over here asking our questions from the book, and I said, after you ping Google, look at the IP route command again. Which route was chosen to send the ICMP message out, and how do you know? Let's go look at that. Can we prove that to ourselves, guys? Because I tell you guys often, like, as engineers, when something's, so if Sending Grounds is here, and I throw them the keys to my truck and say, hey, go buy everybody, like I got a shaved ice place down the road, go buy everybody shaved ice. He would put the keys in my truck and start it, and if it started, I would expect him to just drive off. I wouldn't expect to come out 5 minutes later and see him kicking the tires and looking in the engine and go, oh yeah, the engine's engineing. Like, I wouldn't expect him to be doing that if everything works. And that's how a lot of this engineering stuff we do is, in that if everything's working, you never have to dig in. You follow the standards so that everything works, but then if something breaks, we have to go look at it, right? This is like simple troubleshooting. But what I'm saying is we're going to ping -c3 www.google.com. And what did that do? Well, that went and resolved a common name that we understood, like we can understand that as humans, www.google. And it did a DNS resolution at layer 7 to this IP address, 142.251.40.164. All right. Then I go look at my routes. And I say, okay, 142.251.40.164, how is my system going to choose to get there? Well, it tends to do this thing called the longest prefix match. And you say, well, what the heck's a prefix? A prefix deals with the mask that you get, the net mask. And this is, if you guys have ever heard of net mask or subnet mask, this is it right here. So let's look at these routes that this thing's going to go. And we're going to start at the bottom, because you probably surmised it. Definitely use the top one. But let's not say that we knew. Let's go to this bottom one and say, okay, the destination, if the destination matches 172.30.1 at these 24 significant bits, and you say, Scott, how did you get 24 from 255? Well, we're looking at octal bits, right? We're looking at bits down here in what we call dotted decimal notation, and we're looking at 8 bits, 8 bits, 8 bits, and 8 bits. And when all 8 bits are on, you've got 255. So 8 bits, 8 bits, 8 bits, 24 bits right here. Suffice it to say, 172.30.1 has to exactly match 142.251.40. Does that match? No. Kick it down. It did not match this rule. It does not go out ENP1S0 at this time. Then we come here. 172.17. That's the significant number of bits. And you say, how did you know that? Well, over here, 255 is 16 ones in a row. So the first 16 bits of this are significant. By the way, if you say, well, isn't that 8, 16, 24, 32? You're a genius. That's how networking works, right? It's our IPv4 addressing, right? 255.255.00. So does 172.17 matched at these number of significant bits match this? Oh, hell no, not even close. Okay, so boom. Now, if you get to the end of a routing table and you don't have a default gateway, or you do not have what we call a default route in switches, or in routers, not switches. In routers, we have default route. Here, we've got a default route as well, or we might call it the gateway of last resort in Cisco sometimes. Now, I no longer have to match anything. Actually, in this case, I'm going to not worry about any of them. It's just going to go to that gateway no matter what. And in this case, we're just going to match it. It's just going to match no matter what. So boom. And this was because the last option, by the way, if I don't have a route, if you don't have a default route in Linux, by the way, this happened when I was just building Werewolf out again. I didn't have a default route. Nothing connects anymore, because when you're the way the kernel treats a packet is the same way that a Cisco device treats a packet. If I get to the end, I'm like playing hot potato. If I don't have anything to do with it, I just drop it on the floor. Sometimes I log it, sometimes I don't, depending on the device, right? But anyways, this is how our system got out, was the default gateway. Now you might say, Scott, wait, the default gateway is right here, and down here you said it didn't go this way. It didn't go this way because of this rule. It went that way because of this rule. And you might say, Scott, why do I need to know that? Why are you hammering that? Well, because if you go look at 30 systems and 2 of them aren't working right, and you see that they don't have a default gateway, you might just put the same default gateway as everybody else and go, oh, it worked, but this is why it didn't work, or this is why it worked. Does that kind of make sense? Again, it's one of these things where I've made my whole career just playing Sesame Street. One of these things is not like the other, and making things look the same, and then they work. But we want to know why they work, right? We're engineers. I may have to build something again. I may have to do that same thing, but in a different environment. When we switch environments, right, we get very complacent in the environment that we're in, and then we move to a new environment and shit doesn't work anymore, and we're like, what the heck's going on here? This is how we figure this stuff out, right? I say, after you run the timeout command, see if you can modify it to timeout after 15 seconds. Oh, we've got more stuff here, so let's keep going through here. Check the open ports on the system. So now, I often tell you guys, so, you know, I do a lot of interviews. I haven't done a lot of interviews lately, but I do a fair amount of interviews in the industry. And one of the things that, if you ask somebody to list all the open ports on a system, they're always going to tell you Nmap, because that's what all the books say. But what if I told you Nmap is only if you don't have privilege? If you don't have access to that box, Nmap is an awesome, hey, I'm on the outside looking in. That's an awesome way to map things. But if I'm assuming you're an administrator, Nmap is not the right answer. Nmapping my boxes is probably one of the worst answers if you're a sysadmin or a systems engineer or whatever. Because SS, I have all the permissions. I can be, think about this. If I were to tell you like, hey, from like across the room, look at that piece of cardboard over there and see if there's any like light shining through the cardboard. You might be right, and there might be something on top of the cardboard, like a firewall. But anyways, what if I told you you could get inside of like you could be right next to the cardboard, and you could like shine a light from behind the cardboard, and you could actually then see all the holes that were actually exposed? That's kind of like the difference between looking at something from the outside and the inside. You have a lot more ability to see what's going on when you're the root user. So all I'm saying here is, yeah, SS is my favorite for this, because now inside my system here I can use SS. Now let's take the command apart that I did here. I'm going to clear the screen real quick. I'm going to make this slightly smaller for a second. Go down to like we're at 5. Let's go to like 3. Let's do an SS real quick and make it a little wider. All right, here's a bunch of stuff going on in our system. And I say, okay, there's all these things going, but I just want to see the TCP and the UDP that are connected, right? TCP, yeah. And I also want those are the ones that are established. NT. Let's just take off different ones so I can show you what they do. If I do NTUOP, it gives me everything, right? But I'm going to take away the P, which forces the port number. And this one's kind of important. Oh, N is the one that takes away the port number. My bad. Let's put the P back on. Let's take away the N. And it erases the need for these to be forced to be the ports. I prefer seeing port numbers. Some people like seeing the definitions here. Let me show you something, though. This is important in case you guys didn't know. These are all referenced in real time from a file called the etc services file. And I'm going to prove that to you here real quick. Let's do our SS command. And there is SSH, which, by the way, we're going to do something real quick to just kind of clear the screen up a little bit. We're going to do SS-NTUOP, and then we're going to grep-I capital E for 22 and or SSH, right? So real quick, we see SSH here, and then we're going to take away the N real quick, or we're going to put the N back, N, and we're going to see the 22. So we see 22 or we see SSH, right? Do you guys see that? It's the same output, but we're just forcing it one way or the other. Now we're going to go mess with the services file. We're going to etc services, vi etc services. And down here, I'm going to change 22. I'm going to comment it out. I'm going to YYP, and I'm going to change it from SSH to streamer. All caps like that. Doesn't make any sense, but we're going to do it. And I'm going to go here, and I'm going to do an SS-NTULP, and I'm going to look at it that way. And I'm going to take away the N. And now you're going to see the resolution of that, the real time it went and mapped out of etc services the word streamer instead of the word SSH. Now what I'm showing you there is not super useful. Like don't fucking do any of that stuff I just did, except to know that that's where your system is finding things, right? That's where your system is going. Don't go modifying that file too often, but this is where things are happening. So I'm gonna DD, and then what the hell, DD, and then X. Right, put our file back the way it was. Typically, you'd actually probably make an original version of that file before you touch any of that. But now we'll go do our test again. It's back to SSH, and then it's back to 22. Well, it never changed off of 22. But what ports are open on our system? SS-NTUOP will show you all of them. I can look at the server and say, okay, he's sharing out 22. He is definitely listening. He's not sharing it out. He's listening on 22 for TCP connections from anywhere. He's listening to anybody trying to connect. And he's also doing some other ones that are not super interesting to us. But let's see if he's doing container D. He is doing container D. Container D is going to allow me to either locally, or if it's listening like this, it's listening from anywhere. We can probably run containers on that remote box if we had access to the server. So that's not super secure. We don't normally do that. But let's see if I wanted to go ahead and throw those in. We see that they're running. And then let's go look at what open files and what file handles and processes are touching port 22. This is super useful if you ever come to a Linux box and it's like sitting out in your DMZ and you find out that it's just got open ports and open connections to stuff outside of your world. Like it's got persistent connections, reverse shells out or something like that. And you're like, what the heck's going on here? Somebody obviously clicked something and did something they shouldn't. Well, you can actually go see what processes are holding that open. You can go see if those are daemonized, if they're going to start back up. You can do whatever you want as far as seeing what's actually doing something that you might consider malicious, right? And then I say right here, timeout on our own machine and see if we can do a net connect. This is netcat. So netcat is the basis of all nmap. And we just check to see if our system can connect on port 22 to itself. And when we did that, let's make this a little bigger again, we see that we got a header back. This is one of the reasons why we talk about security by obscurity is not really a thing. So you take your port 22 and you move it to 10,022, 10022, and you're super happy as an organization. You pat yourself on the back and put all your servers out on the web, and they start getting compromised, or people start pen testing them right away, trying to get in to the different users, and you're like, how did they know? Well, because it is still a SSH server, and connecting to that server is still getting a header back, and the header is giving, in this case, the version number. You probably don't want to do that, right? You probably don't want to hand that much stuff back to people, but you can. Let's go look at container D. Container D is running. Let's stop container D, and then let's go look to see if container D is still being shared out like we saw earlier. It's not. We stopped the service that was running it, so we no longer see container D running on our system. Nope. But we still see SSH. Right? We still see SSH sitting down there. But we stopped container D. All right. So now we're going to check some network traffic on our server, look at the throughput of your interfaces, and then we can even grab some PCAPs and stuff like that. I want to rewrite. I'm not going to rewrite this lab, but I'm going to add another one later that uses a tool called ngrep. Ngrep uses the same kernel filter watching functionality to see what's coming in or out of our system. But let's say I come back over here real quick. This over here a little bit. And let's go look at, we can look at ifstat to see the I/O of our system, kilobytes per second in and out for our ENP1S0 and also our Docker. And this is going to do every 2 seconds. It's going to take a slice for 10 iterations. So 20 seconds worth of this running essentially. And there's very little traffic coming in or out of our system. So maybe we go do a TCP dump on our ENP1S0 interface. And we've got a bunch of different values here that kind of matter a little bit. -S0 will get the entirety of the packet. -C is your count. But let's run this real quick, and it's just going to dump a whole bunch of screen. Now, it's kind of funny. This is almost like a, I don't know how to say it except like a self-fulfilling prophecy, in that the system is sending us, we're actually seeing an output. So when we see that output, that's also triggering one of these events. So this should actually be done really quickly. Should have hit 1,000 already, I would have thought. It's probably actually just slowed down by the fact that it's coming to a slow terminal. But we captured 1,000 packets, and then we received them by a filter. And these are full-size packets, but we're only getting this small little part of them, right? We've seen just a little bit of them. We could then take this and we could throw this, we're going to make this little background file, or we're going to make a little background of a bunch of pings to generate traffic, because otherwise this would be really quiet. So we're going to generate a bunch of background pings, and then we're also going to capture that same thing again, and we're going to use a -W and throw it to a file. So there was our, what did we save, 200? So we just captured 200 of them to a file. And then you might say, well, where'd you put that? Was that down in root something PCAP? Can you read that? Hostname is Ubuntu. So ubuntu.pcap is what was rendered. What happens if we do that? That's in a binary format, so we can't read it correctly. What can read that correctly is Wireshark. Typically, we take these, we capture, like places I've used these is we had a big tool called oh shoot, what was that tool? It was Avamar. Avamar did backups, and the vendor had come in and said, hey, you know, we had bought a new version of it from them. And the person who did pre-sales for us, pre-sales engineer, came in and he took a bunch of information. And one of the things he did was he took an IP address where we were sending stuff. And then when the actual engineers came in, I'm talking forensics now. I was part of the fixing the problem. And I'm telling you what happened so that you're not surprised by what I'm about to say. So then he took that and took that IP address or whatever value it was that we were dumping data to, and he put it in his new configs because obviously that's what he thought he needed. He didn't know that in the new system we had to move to this other set of servers. So anyways, we started running, and the security team noticed this problem. They're like, none of the data is going to the new location. We're not getting any data to the new location. So they said, Scott, get on a call with us. Let's figure this out. So what I did was I went and I did a TCP dump like this. And I took that destination address that we were supposed to be sending stuff to, and I proved over the course of 10 minutes with starting and stopping this that we were not sending any data over there. In fact, then I took that off and I said, okay, what's the port that we're trying to use? And I'll just blanket look for anything. And I found that we were all sending them to the old one. And I said, well, aren't these the new clients? And why are they going to the old one in the config? And they were like, oh. And like one of the guys on the call like made that noise. And he went and he looked at his face, like he's like face palming. He's like, guys, our guy put the wrong config. He put the old, we put a brand new agent. We did all this new stuff. We were ready to point at the new place. He pointed at the old one, like the one that was getting decommissioned. And he did that because pre-sales had come in and done their work and all this stuff. Some probably back channel communication that needs to be checked and fixed on their side. But on our side, we found it because in the wild, it was going the other way. And we just use tools like this. Like these are simple tools that can tell you where your systems are trying to communicate to. Because look, communication wasn't broken. The agent was starting. It wasn't like the agent was stopping and going, oh, I can't do anything. No, the agent was sending data somewhere. And when we went and looked at it, we just determined it wasn't sending to the right place. We knew data wasn't going to the right place. We had an empty storage volume, right? Our storage guys were like, what the hell's going on here? And I'm like, what the hell's going on here? Because from my side, like the agent's up. I got the config from the vendor or whatever. Actually, I wasn't even part of the build process. That was somebody else on my team. They called me in to try to help troubleshoot it though, right? But we use these super simple little tools to dig this stuff out, right? All right, anyway, so after you run the timeout command, can you modify it to timeout after 15 seconds? So that was this command. This was earlier. So we did a command on, where was our time? Our timeout was right here. And I said, could you modify it for 15 seconds? Yeah, it's not too hard. And after 15 seconds, this will close that connection. Time and timeout are two of my favorite commands in Linux because they wrap a command in either a limit of time that you're allowed to have, or they limit a command. They wrap it and then they look at all the system and user calls that are made. They give you the user time, the system time, and the wall time of the system. Xshanya, yeah, it's a little bit longer of a stream. I'm just kind of hanging out here. Leith, netstat is a good one, but netstat's a little bit dated, and I don't even think netstat's on these anymore. Oh, they do still have netstat. Most rel systems that I've been on recently don't have netstat by default. I don't know if they've completely deprecated it, but you won't see it on there. But with netstat, you can do the same NTULP, and then it'll just link down to exactly the things that you want. Okay. I said, what ports was container D listening on? Well, we might have to restart the service for that. Systemctl start container D. And then we can do, I can't do Control Shift R in here because it'll refresh this, right? Oh, whoops, I didn't mean to do that. That's actually funny. I can answer that for money. That actually pops up if I have my, I don't have StreamerBot. Oh, I do have StreamerBot on. If I have StreamerBot on and anybody does an exclamation mark ask and like ask me a question, it'll do that. All right, let's throw that in there. We already did that, and then we ls-lh that file. and we saw how big that file was. This will take a few seconds. And you might notice that, like, Scott, you're kind of fighting with the output of a terminal. Well, a terminal can only do standard input, standard output, and standard error. But if you're doing standard output backgrounded over what you're typing, yeah, you're gonna lose your spot in the terminal. However, the terminal remembers. So if I had been typing something and I had properly typed it and then hit enter, it would have been fine.
I can answer that for money.
My favorite alias. I don't know if I have a favorite alias. I don't like really bring aliases with me. I don't intentionally use any aliases either. But I guess if I had to say my favorite alias that I've ever seen, I've seen some good aliases in my time. I have to think about that. You know what? It's funny. The kubectl one, that is a good one. K for kubectl. I did my entire CKA and CKAD by typing kubectl out the whole time, even though I knew I could do K. I was just kind of like brute forcing it or whatever. So, okay. So then we do ls-lh and we see that it's about 21K. That's not a very big file. And you can tend to run TCP dumps for long periods of time if you need to. But I would advise not just dumping everything that comes in or out of your server, but more protect the things that you need to and then track the things that you need to. Like, are our systems going where we expect them to? Are they not? All right. By the way, that's the end of that lab. I said looking at if stat, right? So did we do an if stat? If stat. We did do an if stat. So bang 93. If stat. I said looking at system or at if stat, is this system using a large amount of its interface bandwidth? Why or why not? Well, we can say that this system's not really doing much of anything. It's just kind of hanging out. And then digging deeper, I said, what does it mean to run a dual stack of IPv4 and IPv6 interfaces? What are the use cases for it in the industry, and why might you want to turn that functionality off? I have been in both use cases in my career where I either wanted to run a dual stack because I needed to still support some older technology that was just simply not going to work with IPv6. So some older technology that had to use IPv4 as like the service base, like just the tooling used IPv4. And in that case, you might still need to keep IPv4 in your environment. And I've also worked places where we've had to turn off IPv6 because IPv6 was breaking the environment. Specifically, and recently we went to like a Rocky, well, this was a year and a half ago now. We were working on moving to Rocky, sorry, not Rocky in this case, it was Rel 9. We were doing Rel 9, and the IPv6 interface for Rel 9 was doing a bunch of these calls with its version of ARP, whatever IPv6 ARP is called. I don't even know what that is. And it was doing a whole bunch of these calls, and it was bogging down and overloading our GPFS system. So we had to remove that. And we found that because it was doing like 16,000 calls per second per each of the interfaces connected, and we only had like 2 or 3 test machines up. And we were like, this is going to crush this. It was already crushing the system with only 3. We had 1,600 nodes in the, 1,200 nodes in that cluster. So anyways, the point is, sometimes you want to turn them on, sometimes you want to turn stuff off. I don't know of a place where you would only need to run IPv6 as an interface yet. I know that some big cloud providers and ISPs are all IPv6 under the hood. But I'd be willing to bet if they're running like internal Kubernetes, they probably have IPv4 somewhere in their organization. So yeah, Sending, I appreciate you coming by. Yeah, you're definitely welcome to hang out whenever. All right, our environment's about to collapse here, so we're going to move back out. And then the next part of the book is SSH and SCP. So we're going through the book as we do the labs. The labs are completely free up on Killer Coda. You guys can jump in them and do them with us here. Hey, thanks for the raid. How do I say that? Panko. Hopefully this stuff's useful to you. We are on Twitch and YouTube, and we are just doing labs and kind of going through Linux, learning how to, or I guess walking through how to do different things that I think an administrator needs. We have lab environments up in Killer Coda, which is a completely free site that you guys can just hang out in and do kind of whatever, whatever you want in there, really. But in our case, we've got a book that goes along with it. The book's kind of like a little study guide. And here's what we're doing. It says you are a new administrator, and you need to connect to the main jump server from the main jump server to another server in your organization. So again, you're just some new admin in a company. You've never done this stuff before. You realize that you need a better understanding of the SSH connection process. So you want to see how SSH works. And what I want you to do is connect to the other server and look at the specifics of how SSH is working, right? Yeah, how's it going, guys? Yeah, I'm just kind of hanging out, and on Sundays we do labs. So labs are from our lab book. I appreciate the follows. I tell you guys all the time, you might not find your favorite streamer here, but maybe if your favorite streamer's not on, you're always welcome to hang out with us. We also have down in our Discord, we are constantly doing a bunch of like events and stuff like that. So you guys are welcome to hang out down there. We got about 4,200 people down there as well. My content scares you. It's not that bad. I will tell you, this is not for everybody though. Doing all command line system work is not a thing that everybody wants to do. But you guys are definitely welcome to hang out with us as we talk about it. Our Discord is right here, and we were looking at some lab diagrams and stuff. But I always tell people, everything we do here is free. We've got a writer's room for people that want to work on the books. We have 2 free books that are out there. I linked them a little while ago, but they're also down in the system. I do Prolog Lab Maintenance. That's a professional Linux users group lab maintenance on Sunday nights. So at 7 o'clock, which is, 8 hours from now, I'll do some maintenance and stuff in there and show you guys cleaning up the environment and all that stuff. Yeah, I definitely appreciate you guys coming by, though. Bash Study Group, those come up every Saturday, and then we have the courses that are coming up again. These are free courses that we run. The security engineering course is coming up again, and then also the 16-week automation course. So you guys are welcome to come and hang out with any of those. We sometimes get, we've had hundreds of people start those. We've only had about 20 people finish them, but that's because there's a lot of work there. All right, so we're new admin. We're going to do something. We're going to SSH over to node 01. How did we know that that was node 01? Well, we may have just known this environment. We can also look at our etc host file and see that, oh, here's this host 01. He's the other host. We are control plane. We might see that with host name. We might see that with, that's probably the easiest way, host name. But we also sometimes see a host name right there in our command prompt. Our command prompt is a variable that we can modify in any way we want. It's called the PS1 variable. Some people love to modify these things heavily, but I don't see a need for it in my world. But sometimes people like to modify those things heavily, so that's how you would change that. But suffice it to say, we jump over to that system, and now we are on that system. And then we exit back, and we're back on our system. That's a very important kind of workflow to understand. Like if you guys have ever watched me in my home lab here, I'm in the Rocky 2 box, now I'm back in Werewolf. Now I'm up in Rocky 4, now I'm back in Werewolf. Then I'm over in Auto 5, Auto 4, now I'm back in Werewolf. And I'm jumping into these different environments. And sometimes I got to push a file up into Auto 4. And there's all these things that you'll kind of pick up in your workflows. And I'm not going to tell you the only way to do something. I'm not going to tell you any one way is best, but you definitely have to figure out how to do these basic things so that you can then use them in your workflow as an engineer. So right here, we SSH over, we back out, then we SSH over again, and we just run a command. So this command where we SSH over, we can also say uptime like this, and we will SSH to that node, do the uptime command, and then come back to our node. So we don't ever really land over in that system. We just do, in this case now, host name and uptime, and then we're back on control plane. We never stayed over there. We just issued a command. It's like I said, hey, tell me your name and your uptime. And then you came over and you just yelled it back to me. That's kind of what happened here. But I say we can do those commands and we could add a -v. Now this is going to be very verbose, but it's very important to understand that as you look at these things, the verbosity of a thing is kind of where we're troubleshooting it. Look at that, that just blew up my screen. But what did I see here? I saw that when I called SSH, I'm calling the open SSH. I should be doing, this is my OpenSSH client on my system. And you say, well, how do you know that that's your OpenSSH client on your system? OpenSSH is the client going out. Well, we did a lab a little while ago, dpkg-l, and then like, right, here's OpenSSH, and here's my client, and here's my one, so here's the version. It's 1:9.6p1 whatever Ubuntu. And it's a secure shell client for connecting out somewhere. So that's what we just called right here. We read his config file, which is an etc ssh underscore config, as opposed to the other file is etc sshd underscore config. That's our file for our server. So our connection out used this. We read that file, and then we didn't find any additional config files. That was what the .d directory always represents. And I don't have to step through all of this for you guys because it'll get real boring. But suffice to say, down here, we looked for identity files for how we were going to prove to that server on the far side that we were who we said we were. Right? This is identity. So it's we do authentication where we prove we are who we say we are. And then we get authorization by the far side to be allowed to do things, right? That's part of the AAA model. It's authentication, prove who you are, and then authorization, do the things you're supposed to do, and then auditing to make sure that people only did the things they were supposed to do, right? So we come over here, and the only one that was found, this is actually kind of funny because this goes back to like an old, this is probably written in C. See all these ones that have a -1? Not found, not found, not found, not found. Some of you guys that have Java backgrounds also probably see that because I know that Java does that as well, right? So the only one that was found is this one right here. We could also, for fun, if we wanted to, go look in our root.ssh, but that's the only one that's found, the ID underscore RSA. All these other types, not found. That's what that -1 means. So then we come down here, and it goes local string version this. So now this is where we started to connect. This is our local side. Now we're going to go connect on port 22 to the far side, and we're going to read the header. So here's the banner match of that header. This is the same thing as when we did a netcat a few minutes ago and did a netcat on port 22. So watch here. So NC node 01 on port 22, and we got this banner header back. That's what the header is being read right here. Now, one of the things you guys might notice, you might say, Scott, this is a lot of stuff. I don't really care about all that. And I tell you, this is always true. If everything works, guys, we don't ever go and open the hood of the truck, right? We only open up and troubleshoot the thing if it doesn't work. But I'm showing you this because as an admin, understanding how your tool works may help you if you get stuck somewhere. Man, I can't get to node 01, and I keep getting a weird error, but it's not like any of my other weird errors. It's more like it says it can't find the host. Well, look, guys, if you can't find the host, you're not resolving the name, or you don't have the name in your Etsy host. That is a totally different problem than like his SSH being down, right? So there's like these different things. You might have to jump over into that server. You might have to do something like this. Where's my, you might have to go jump into one of these nodes, right? Like this, I jumped into this node. I get into this node, and then I say IPBR and I say, oh, his IP address is 192.168.200.151. Shoot, I didn't know that was the address, so I was hitting I'm looking at something completely different. Well, that's a real thing. Improperly mapped names in a network are extremely common if you're doing systems work, right? So anyway, so we added the 1V, and we saw some information. In fact, we see debug version level 1, and look, it just keeps going down. It does some checks to make sure that the host is who we think it is. It checks some things. It starts handing keys over, and at the end of the day, it either accepts the key or it doesn't. And then once it does accept the key, then it gives us the output right here. So it actually gives us the output of the command that we wanted, and then it breaks down the communication. So this breaks down the communication right here, and everything's good. It says how much bytes per second we sent and received, because maybe that's important to us. We get down here. Let's do that same uptime command, but let's add another V. So now we're going to see debug level 1 and debug level 2. So we come back up here, and something that's kind of nice to do sometimes is we'll do a whole bunch of enters, right? And then we'll do the debug version 2, right? So that then when we go up, we can see clearly where our command started. So we did 2 V's, right? More verbosity. And we're debug level 1. And then now, here's debug 2. Debug 2 shows us something that happened on the server side of our system that doesn't really have anything to do with SSH. Our system was asked to resolve node 01 on port 22. So if something broke after this, we would maybe know that our system didn't resolve. But our system did resolve node 01 to 172.32.2. Most all of your applications, everywhere you're ever going to work or anything you're going to write, will do their node resolution or their name resolution once at the beginning, and they will use that name or IP address or whatever for the rest of the time. This is one of the reasons why it's so important in like Kubernetes that we have a service sitting in front of pods. Pods are ephemeral. A pod can die and come back up with a new IP address at any second, at any moment. Shouldn't happen too often, but it could. So the service that sits in front of it and typically load balances a bunch of pods will always be one place that you can point to. So if this were trying to hit an application of some type or something, doing something other than SSH, it would want a static's not the right term, persistent non-changing IP address, and that would be kind of what this is in this case. All right, same type of thing. None of these are different because they're all debug 1. Where's our next debug 2? Debug 2. Now it tells us the file descriptor 3, and we're setting O non-block for file descriptor 3. That might not mean anything to anybody. It does mean something to people that are writing the C-level programming for it, but this is a very low debug of what's happening on the system. If this errored because maybe file descriptor 3 was being used in the file system, then there would be something wrong where maybe there was a timing issue between when it was checked to see if it was free or when it got locked up. There's all kinds of things that could happen, but at my level, at an admin level, let's say, I would just want to know that that's where it's breaking, and then I can go figure out why that's happening. Oh, we have too many connections out and we're going over some limit of how many file descriptors we have or something like that. I don't know, whatever that problem could be, we can go start to track down. That's why I tell you guys all the time, like if something just works, you don't ever have to dig into it. But all right, so anyways, we do that. Come down here and then we could do 3. 3 gets really messy. Like 3 goes real deep into the actual syscalls. So let's go look at 3. It still did all the same stuff. It's going to start the exact same way. But then when we start getting to the 3s, see, debug 2 is still. Let's go find some 3s. All right, so here's this. 3. Expanded user known host file, that root SSH known host. So debug 3 is showing us that we went to look at the SSH known host out of our home directory, right? That tilde means our home. And if that didn't exist, that might be where that breaks, right? Expanded user known host file from host known host 2 in there. So we have 2 known host files. That's weird. And we only have the 1 known host file. I don't know why it has the second one there. Maybe it's going to compare them later. I'm not sure. But the point is, we now have these. And then it says for debug 2 that it resolved that port. That's cool. But now debug 3 is even deeper. It said looked up node 01 on 22. And then it said channel clear timeouts clearing. And then it said SSH direct connect entering. Or connect direct entering. I don't know. That may be a call inside of the program. That may be a function. That's a deep level, again, layer 3 debug of what's going on. So we're not necessarily, the purpose of these labs isn't necessarily to dig deep into this. What I want to show you guys though is you have a lot of options for really digging into what the problem is if you don't just get a connection. It doesn't have to be like, well, I couldn't connect, boss, and then I hung up the phone and went back to sleep and didn't answer any other on-call calls, and I just, I know our system was down for 16 hours because of me, but I should still keep my job. And I can almost guarantee you won't keep your job if you did something like that. But this is the idea of, like, if you're doing Linux work and you're fixing things, these are how we kind of want to do them. All right. So anyways, you're tasked with pushing a new message of the day onto a server. So message of the day files are a way that when we SSH to node 01, we maybe want to drop a banner on people for an actual message of the day. Or sometimes we just like to let people know what environment they're in. So message of the days have different functions. Some admins still heavily use them and love to share them around. I tell you, most people it's just noise, so they ignore it. But We're going to push it over there. Then we're also going to pull an Etsy cron tab from that other server back to here. And the reason we're going to do that is because we want to keep maybe that Etsy cron tab from like a new server, and we're going to pull into our, some environment we keep or something. I don't know. So we're going to push something, we're going to pull something. SCP is always in a to from format. So I SCP from here to there. If I had some, I'm on node 01. Let's go to control plane. And let's just touch Scott file. Doesn't matter. And I'm going to SCP Scott file to node 01 in temp, right? And then I SSH to node 01, CD to temp, and then there's Scott file right there. Doesn't have anything in it, but it moved the file over there, right? So I can SCP from here, and I use a relative path local to where I am, over to that node, and an absolute path over into its temp directory, right? Move back out. We can do SCP. So let's push and pull these things around. So let's checksum cat root motd. It's a big old dev box, and we can checksum it and see that that is the checksum, kind of the weight of that file according to the checksum protocol. Now we're going to copy it from here to there, and we're going to SSH over there and see that that is now the Etsy motd. It is the message of the day on node 01. It wasn't there a few minutes ago, a few seconds ago when I went there, right? So there's that. Fucking Ross. How's it going, Ross? I'm surprised you're cutting out so early today. It is, well, I guess it's kind of later for you guys. Hey, we are doing Linux here. You're the second raid of the day. And what we do in the Professional Linux Users Group, if you guys don't know me, I go online by the moniker Het Tanis. My name is Scott Champagne. I don't flex nearly as cool as Ross, right? Like Ross likes to flex up a little bit, but I don't do it as well as him. And what I do, follower only, I think it is follower only most of the time. I don't know if I ever have turned follower only off. But anyway, so what we're doing right now is we're pushing and pulling data around in a network, because let's say you wanted to be a Linux administrator. Let's say you got a wild hair up your ass to go and change industries and just look at black backgrounds with green or white letters all day like I do, because this is literally all I do as an engineer all day, is just look at this. And what we're doing for right now is learning the tasks of how to push and pull things around the network. So I'm on a server. Oops, didn't want to do that. I'm on a server called control plane, and I can move into the server node 01 via SSH, right? SSH is secure shell, and we jump around in the environment, right? Teach how to hack Rossberger's heart. I don't know. Rossberger, I think he wears his heart on the sleeve. So, I mean, guys, I probably spend an unhealthy amount of time in Rossberger streams during the day, because, like, I go and I train Brazilian Jiu-Jitsu in the morning, and then I just kind of sit here all day on my little ball and I work on a big set of screens here and a set of screens over here. And Ross is kind of like my morning wake-up music most of the time, you know. And I'll have to turn it down sometimes because my wife will be coming in and like, what are you listening to, all that moaning and stuff? And I'm like, you don't even want to know, wifey. Like, you literally don't even want to know what's going on over here. But anyway, so actually this is a shirt for my wife. It's a Linux and ASCII art. So, also apparently my screen's busted. Hold on. Normally, as I'm talking to you guys can see what I'm talking about right there. So hold on, let me get all this back up. That's kind of annoying. Yeah, normally you guys can see me talking. I didn't realize that I had stopped that, or that it had stopped itself. So yeah, I appreciate you coming by, Ross. It's always fun. I spend a lot of time in Ross's channel. I don't know, I probably found Ross about 3 or 4 years ago on Twitch. And so for people that don't know me, or people that are in my community that don't know me, this about me, I have like an unhealthy obsession with like watching Dead by Daylight. I've never played the game. I have all kinds of games I do play, but I've never played Dead by Daylight. I love watching people get hung up on meat hooks. I don't know if that's because I was a combat infantryman. I don't know if that's just because I like horror movies, but I don't like having to be invested. This is what I think. I don't like having to be invested in the movie. But that's how, like, Dead by Daylight, they're just running around getting thrown up on meat hooks and stuff, and I think it's hilarious, but I don't have to actually watch a story. Does that kind of make sense? I think that's one of the reasons I like that game so much, is it's kind of fun. Sending Grounds is back. How's it going, man? But no, I'm definitely a big fan of that. So this thing over here on the right, these are kind of like our notes, or like this comes from a book that we have. And it's task, condition, and standard, which some of you may notice from the military, right? We have a task to do a thing. here's our condition. You're given 60 minutes to do this thing, and you got to do all the activities. That's what we do. Now, the lab walks you through. The lab tells you exactly what to do. You can check some of file. Whoops, I'm on the wrong environment. You can check some of the file. You can copy the file over, and then you can SSH over and see that the net effect of what you did was good, right? Then we come over here, and then we SSH over there, and we make sure that there has been no change in the file. When the file was over here, and the file was put on the new server, nothing changed. It's like I always tell people, it's like that Indiana Jones. You guys see where he's looking at the thing, and he fills up the sand, and then he pulls the little idol off and puts the sand on? Anybody that's ever seen that scene knows that he messed up and immediately gets chased by a boulder, but that's neither here nor there. Yeah, sending. I definitely look at Linux all day and see servers and users just crashing and destroying things. And my the job of a Linux admin, for anybody that really wants to know, is really just like cleaning up messes and just being like, oh my god, who put this mess here? Like, how did this situation get this? How did this poor server that I built correctly years ago get in this bad state? But people that want to know a little more about me, I am a high-performance compute engineer for NOAA, so I work for National Oceanographic Atmospheric Agency, but I do all that through a company called Redline. That's my normal employer, and then I'm kind of like a government contractor. I do all kinds of other tasks around the interwebs, and one of the things I mainly do is secure government systems, right? Like I build these things called STIG standards, and I deploy them, and one of the things I kind of excel in as well is over here in our Discord, I was showing this earlier, is building jails, building bastion jails to allow users to come in to an environment, but then they're kind of not quite sanitized. I wouldn't say sanitized, but the users are locked in, and then they can only go to the places that I allow them to. Sending, I don't know if you heard yesterday, I don't know if I told you this, but we got royally like smacked by a pen test the other day. So penetration tests, people came in and tested, but pen tests kind of feel dirty because it's like, it would be like if you came in my house, like if I let you in my house and then you were like, there's dirt in the corner over there, and I'm like, there is dirt in the corner, but you would have never found it if I didn't let you in my house. And they're like, but we got in your house, and I'm like, yeah, because I let you in. And they're like, but I was in there. And you're like, what is this Norm Macdonald shtick you're doing, buddy? But anyways, all right, I'll stop here. Oh, we got sending. I'll tell you like down later, but yeah, we got smacked pretty hard. We legitimately had a couple things that were really bad, and I was like, wait, we're doing what? Oh my gosh. Oh, okay. Anyway, so let's go look over there. We're gonna take from that node. We're gonna SSH to that node, and we're gonna look at their etc cron tab. Remember, in the lab we said the etc cron tab on that server was good. For some reason, we broke them everywhere else in the environment, and we want to steal it from that node and bring it back. SCP is just a secure copy from that node to this node, and then we're going to check, and it's going to be exactly the same. So some of this is like us trusting our tools, right? Like, look, let me show you. I'm on a Windows system, right? There's no shame in that. I don't mind being on a Windows system. And let's say I just come over here to like my downloads, and I take this Gemini generated image, which I think is a werewolf, right? Oh yeah, this is my werewolf image from my presentation. And if I wanted to copy this from somewhere else in my Windows system, does anybody know how I'd do it? What would I do? Like right click, copy, and then I would go and paste it somewhere else, right? Just paste it. Well, wouldn't that be like, wouldn't I really think about this for a second? That's all kinds of bytes of all kinds of gobbledygook in JPEG format on a Windows server or on a Windows system somewhere. I'm really trusting a lot that when I move that somewhere else that it worked, right? I mean, maybe I put it in the new place and then I open it and that's how I verify. Well, in the Linux world, we only have this. We have a black background with white or green letters. This is all we have. So one of the things that we do is we weigh something before we move it. We can use checksum. I could also use this. Let's do, instead of checksum, I use like a SHA 256 sum, right? So I can do a SHA 256. It would help if I type it right. And I can SHA 256 sum it over there. And then on this side, when I look at it again, I could do a SHA 256 sum. But this, guys, this would be analogous to me just putting, like, if I looked at the scale and it said I was 290 this morning, I go, geez, I better get a different scale to verify. And then the other scale tells me I'm still 290, and I'm like, Nope, both of these scales are probably busted. That's what I just did. I changed out the method by which I weighed them, but they still weighed the same. So the problem was with me, not with the scale, right? Anyways, the reason I'm saying that is because we have to know how our tools work, and then we have to trust them. So all we're doing in this lab is literally just pushing things around and pulling them around the environment. That's the whole thing. So then I said here what additional information is added as you added V to a command. So if you SSH to node 01, you jump in and then you jump back out. But if you add a dash, so we do SSH node 01 and then we say like uptime, it'll, whoops, let's do this. Uptime, it'll just give us the uptime of that node. But then if I add a dash V, it will be more verbose about what's happening under the hood. That's just a big old mess to the screen of my system going and resolving the name. So like sometimes, I mean, if you've never had to troubleshoot this before, you might not know that all this is at your fingertips. And as engineers, we have to, again, if I SSH for the rest of my career and I never have something break, I will never put a V in front of it. But if something breaks, then I will. And I often say this, like with Sending Grounds as one of my mods. If Sending Grounds and I are hanging out and everybody else is hanging out too, and I just toss him the keys to my truck and say, hey, go get everybody ice cream, he's going to go outside and start the truck up. Cool, truck started, drive off. If the truck goes and stops, then he's going to be like, troubleshooting mode. Maybe troubleshooting for him is just coming back inside and throwing me the keys and saying your truck's a piece of junk. That's fair, but we don't have that option when we're the admins. When we're the ones who, like, literally the buck stops with us, we're the ones who have to get the system working. We're the ones who have to work late at night. We have to know how to go dig in and look under the hood. And my first answer might just be like, oh, the SSH isn't SSHing, right? That might be my first answer. I might take all this and throw it in the Googles, right? Not exactly all this, but wherever it breaks. And then we throw it in Google and we go, oh, somebody else has seen this problem. Because that's almost universally true in the admin side of things. It's not universally true in the engineering side of things. When we're building stuff new that's never been built, you don't always have someone to fall back on. When we're building something and fixing something that was working a few minutes ago before the call came out, well, how do I get it back to good? Do I restart the whole thing and get it back to a running process? Do I go look at where it broke? Was it a resource exhaustion issue? I always tell you guys, this is a very important thing for systems administrators to know, is utilization, saturation, and errors. So I have a problem of some type. I look at the utilization between 0 and 100% of something. I'm using all the CPU became exhausted. We started saturation. Saturation is a queue or a line forming of things waiting to get to the processor. And then from that, timeouts started to occur because we can't wait forever. So there's reasonable timeouts built into programs. And then we start to generate errors down into logs. We hope they're good errors. We hope they're useful. But sometimes errors, like an error of a long response, doesn't always mean that the thing that gave the long response error is where it erred. It could have erred on the communication. It could have erred on the far side. It's just one of these things that's an indicator. So the use methodology, the utilization, saturation, errors is just is such a big deal for understanding. And this is I have this up in the Discord, all this is like how you troubleshoot and administration tasks and that kind of stuff. All right, so anyways, let's go back to our labs real quick. So I do appreciate anybody that's sticking around with me, especially people that came from Ross. I do hang out with Ross quite a bit down in the in his channel. Where'd my other thing go? Oh, here's Sumatra. Yeah. So I say when you see an identity file with a 0 or a -1, what does that mean? And what does the identity file being used in this connection, what is that? So we talked about this a little bit earlier, but this is a very common exit code. I've seen it in C. I've seen it in Java. I'm pretty sure it's in JavaScript as well. But if I find something, I return 0. And if I don't find something, I return -1. This is a very common kind of way of doing this, right? Oh yeah, man. I've been. How long have I been? I was in Rossberger's channel before he had his daughter. So yeah, this is a while. It's been a while. Yeah. I've been hanging out with Ross for a while. But yeah, I think I probably started watching Dead by Daylight sometime after COVID started. You know, when everybody was working from home, and I was like, "What is this Twitch thing?" I have a Twitch account, but I don't ever use it, and I started hopping in and watching stuff. And then after a while, I was like, I should teach people Linux on here. Worst idea I've ever had in my life, but I've been doing it. I mean, we got 4,200 people hanging out down in our Discord, so that's pretty good. but mostly just people wanting to get better at Linux and systems work. Oh, I never finished telling you guys about about me doesn't matter. Been an engineer for a long time. Been a college professor for a long time. Working on my dissertation. I actually mentioned that in Ross's stream earlier. I've been working on my dissertation. I actually have a project due tonight on that. I'm almost all but dissertation. I have to do this one last little thing, and then I might just do. If I can do my own data collection, it's going to be awesome. But I don't know if I can do my thing. Oh, wife texted me about food. Hold on. Okay. Let's dig deeper into this. So then, when pushing the message of the day, what was the source and what was the destination file? So that was a command here. The command was we wanted to SCP the root message of the day that we had generated on this node, and we wanted to push it over there. Let me show you guys something fun here, by the way. So we'll cat root motd. I didn't write this myself. That's ASCII art. So if you guys have never seen this, let me show you something fun. Finally, she said you disagree because this is fantastic. I try to make good stuff. I try to make stuff that hopefully is useful to people. Let me show you guys this PJAT, or I don't know how to say it. ASCII. This guy. No, that's the wrong one. Hold on. This is it right here. Yeah, this guy right here. I'll give you guys his link here in a second. I love this. I love this guy's page. I think this is one of the most fun little things on the web. But this guy put this project together. I don't know him. I would if he has like a Patreon or something, I'd give him like $10 or something. But watch this real quick. I can type something here like Rossberger rules, right? I can say Rossberger rules right here. And then I can test all the different ASCII art fonts for Ross. Ross probably isn't around. Maybe I'll go drop this in his Discord. But like, here's all the different ASCII art fonts that might be kind of cool for that. Like if you wanted some traditional, like that's big. That's kind of cool looking one. You can also force them to be all upper or lowercase. You can do all these other things. This one is the one that I'm actually using in that other one. But the reason I don't have super wide ones is because they don't work well in a terminal. Most people don't look at a terminal more than like, I think it's like 85 or 90 characters wide. In fact, a lot of software engineers I know hard force, I forget what the exact one is. Somebody here could probably tell me, but they hard force it. They won't go wider than that. But anyway, so yeah, look at all these. These are just all the ways that you could type out Rossberger, right? And I think this is kind of fun. Because then maybe these ones with the little ghosts, and the ghosts are crawling all over them, that could be like something that you burn in or make part of like an image or something like that. And I just think it's fun. And it's all ASCII art, so it's all art that can be generated from a terminal, right? I can go throw these in a file, and then I could always print that out inside of a terminal with the correct width, right? Look at those little devils instead of the ghosts. I think that's fun. Maybe everybody else doesn't think that's nearly as fun as I do, but I do. I think those are good. Here's slant. That's super easy. That reminds me, this one right here reminds me, slant relief. Anybody here ever played Excite Bike? That reminds me of the game Excite Bike. That's an old Nintendo game from like the early 80s. Super fun little game though. Let's see. There's one that actually looks almost exactly like Excite Bike. Hold on. Where is it at? That one's a little annoying, but that would be cool. That would be okay for like if you had a ticker going across the bottom, like I do. That one might be kind of cool for that. No, there's one that definitely looks. I want to find it now because it's gonna bug me. Chunky. It's pretty good. All right. Hold on. Diamond doesn't look too bad, but no. Dot matrix, yeah, for like a dot matrix printer. That's kind of funny. So I gotta ask a question. How do I recommend starting to learn this stuff from scratch? This is what I would do if I didn't know any of this stuff at all. As a real quick caveat, it used to be you'd have to go install Linux and work on it. What I would tell you now is go get on the site Killer Coda, which is completely free, and I would say go find something that's interesting to you. So here's Killer Coda. If you guys have never used Killer Coda, I have about 80 labs that I've built out there, but this is what it looks like. It drops you in a Linux shell just like this. You've never done any Linux before. You get dropped in a shell. It says you are tasked with doing something. You read down a little bit, and then you get to the solution, and you literally just hit these buttons in My Labs, and it walks you through exactly what the commands are. And you can go see all the things. You can watch them happen. You can kind of start to grok, or what we say as engineers, understand a thing. And I know grok is a thing that like Elon Musk uses now, but it's been in engineering well before he was in engineering. That was a thing, right? Grok it comes from what is it? Something on a empty planet. What was the name of that book? Somebody told me it before. I know I have it in my notes somewhere to go read that book. Prisoner on a Distant Planet? Something. Somebody knows. Stranger in a Strange Land. That's exactly it. Yeah, thank you for that. It was like sitting back here in the back of my head, and I literally couldn't think of the word. Yeah, Stranger in a Strange Land. And you would grok to understand a thing. We would grok to understand a people, or grok to understand. So I know the context of it, but I've never done that. Anyways, my point is, I would tell you, go in here and maybe find something interesting to you, right? Like if you said, I want to learn Linux, there's a lot of people in here. There's a guy that teaches Linux right here, Powell Piwaz. I like his stuff. He will also teach you a tool called Git. My stuff here is like Ansible and HashiCorp. I have some labs on those. And then I have a heavy amount of labs on just Linux. So if you want My Linux labs, they're right here. And it's like a little bit about me, things that people might care about, a bunch of our information for the courses and stuff. And here's all the Linux labs right here. Look around a Linux system, jump in. And again, it's very, I would call this like Linux Lite, because you're literally just pushing buttons and it's doing it for you. And then if you look at that, and let's say you do that, and again, Killer Code is free. They've never charged me in over 3 years of using it. If you look at all that and go, that's not for me. God, I tell people all the time, that's like the best free thing I ever got. Like if I went and washed cars, like I grew up washing cars. Like my dad always made me wash our cars, right? So if I knew like washing cars is not for me, I would rather learn that for free than going and spending a bunch of stuff. Like I tell you guys all the time, like I have college students come to me in years 3 and 4, and they're like, hey, when does it stop being this and start being fun? And I'm like, dude, this is the job. This stuff right here is what I do day in and day out. And they're like, oh, I hate that. And I'm like, fuck, man, that's an expensive mistake right there, because you might want to go be like a project manager then or something, or like a manager over IT. But if you hate like doing this stuff at the command line, I would rather learn that for free on a stream like this than going and spending like years of my life and tens of thousands of dollars in college learning. Look at all that Rossberger rules. We haven't run out yet. There's still more. But anyways, where I'm going with that is, yeah, I would go on here. And then another thing is find other people that talk about the industry. Like I tell people all the time, even if it's not our group, find somewhere. There was a place out here in Phoenix when I was younger. It was called Chandler Mental Health, and they would always have this commercial like, if you don't get help at Chandler, please get help somewhere. And I tell you guys that all the time. If it's not us, if you're like, man, I can't stand that guy Scott for one more second, that's fine. Go hang out with Sending Grounds. Sending Grounds has some really good stuff, and he's on pretty late at night too, so he's late at night as far as tech streamers go, right? So he's an awesome person to go hang with and hack or do whatever different stuff he's working on. Most of the time he's working on like bash scripting and dealing with systems engineering problems. So awesome stuff to get into. Well, where I'm going with that is find people that are doing stuff that interests you and then hang out with them. Because like I always use the example, and I know a lot of people aren't going to get this, but if you haven't ever seen the movie 13th Warrior, you should absolutely stop what you're doing and go watch it. But in the movie 13th Warrior, he doesn't speak their language. He's the 13th Warrior. He was added to all these. He's an Arab guy he's a Spanish guy playing an Arab guy that goes to hang out with these 12 badass Vikings, right? And they go up north to fight this creature, this thing that's killing people in the mist. These group of monsters, right? That's the story if you don't know it. It's awesome. It comes from a Michael Crichton book called Eaters of the Dead, which is a fantastic book in its own right. But I digress. The way they show him learn their language it stuck with me from when I was a kid, so I know it was great. But I love it. It's like he doesn't understand, and then he's like sitting there with them at dinner, and he hears a word here and he hears a word there, but then it's all just garbled. And after time, he hears their language and understands it. And it's actually really funny because the guys are always joking around. They're a bunch of Vikings and they're badass warriors, so they're always like fighting with each other and arguing and making fun of each other's moms and shit. And he's sitting there on his pony when they get where they're going. He's got this smaller horse than all the rest of them. And one of the guys looks at him, and it's finally in English. Everything else has been all jumbled, and he's just been hearing words here and there. And the guy goes, only an Arab would bring a dog to war. And he looked at the guy and goes, the only dog here is your mother. And the guy looked at him, and he goes, when did you learn our language? And he goes, how did you learn our language? And he says, I listened. And then all the guys start laughing, even that guy, because, like, they don't take themselves serious. They're a bunch of warriors. They could die at any time. So they don't take their stuff very seriously. But it's an awesome way to, like, how I look at engineering. Like, how else are you going to hear how engineers talk unless you come and sit with the engineers, right? And I posit, if it's not our group, find some group. Find some people or whatever. So, Amar, you said you were preparing for your CKA. Any tips on copy YAML into terminal? I wouldn't copy anything into the terminal. This is what I would do. So that's a really good question. There was a question about how you would do prepping for CKA. Let me show you how I prepped when I got my CKA. So let's go to my Linux admin course. Let's go, nope, wrong place. Let's go over to presentations. So let's do this. I appreciate that. Sending Grounds gifted tier 1. Hopefully that is useful to somebody who doesn't have to watch ads for a little while. I love Sending Grounds. I love that movie. That scene is so perfect for like how people pick stuff up. But let me show you guys this. This is my, hold on, these are old topics I've talked on. Where's my Kubernetes? This is how I would practice for my CKA. And Amir, you're not going to be able to copy things in. So this is what I would do instead. This, by the way, this right here that I'm showing you is up in Discord. So you can go and download this from our Discord and work through it. Although it's a little bit old, I did update it. This is my CKA preparation, right? And it's got the stuff you already know about the certs and the training and that stuff. But what I like to do when we get done, so here's all this stuff. Again, and if you don't find it, let me know. But it's up in our Discord. Go drop down here. When we get to the end of all this stuff, these are all labs and things that I think that you can go do and look at how to troubleshoot and get ready. But at the end, there's this. Here's a lab pod practice, and I say, can you do these things? And then here's the answers. And then here's imperative. This is what I would learn how to do. And this is what I did when I did my certification. So this is, somebody asked about the CKA preparation, and this is what I would do. I would learn how to imperatively create things, but imperative is not the way you want to learn how to do things in the world. You want to learn how to do things declaratively. What that means is imperative, though, right here, you can use any of these things to create these things. But then you can say -- dry run. I think dry run now doesn't need client anymore. It used to be dry run equals client. Now it's just dry run. And then you can say -o YAML and throw it out to a file, and then you redirect to a local file. So you can, it doesn't matter what somebody asked me to do. Hey, can you create a 3-node Kubernetes with this and this and this? Yeah, I can. And I'm going to imperatively create it. It's going to generate my YAML, and then I'm going to go modify the YAML the way I need. That's what I would learn how to do, because that's how I would build stuff out anyways. That's how I do all my stuff. But here's the different labs. This thing shows you all my stuff in here shows you how to do it all. But my point in saying that is I would not focus on copying stuff out in there. I would learn enough to know everything, and then I would know how to build my imperative. Like one of the ones that would be kind of big is like you've got to generate a network policy, and the network policy has to do something, right? And the network policies are difficult for people. So what I would tell you is you could generate all the structure of the network policy by just doing an imperative command to create a network policy, throw it out to a file, then go modify the file based on what you see. And now you're not like, man, because one of the most stressful things about that test is you only have 2 hours to do like 13 tasks or 12 or 13 tasks. It's, if I'm doing YAML, right? If I'm doing a bunch of YAML, it's like going to be like a page of YAML. And I have any of those fucking hanging indents or whatever, and now I'm just sitting here going like this because it won't take my YAML. That's a nightmare, man. Like, and probably a problem with the pasting as well is like you've got an extra, because if you guys don't know, YAML is bound by the constraint of like how many indents you have, and if you have a space in the wrong place, it just doesn't parse the file. That's like one of the biggest nightmares in all the world. But if you imperatively build something first and let the system build it for you, and then you just go modify the pieces they ask for, you'll be right 100% of the time. So that's what I would learn how to do. So hopefully, Aladay, hopefully that's good. Yeah, I would, $500 in the drain due to YAML. I 100% can see that. Um, how I would practice these, that's what all these are. These are like explanations and the hands-on. These are all the killer coda scenarios, right? And what I would tell you is this, like this is, like, can I show you how I get ready for certs? Because I remember this came up long ago in RWX Rob's chat, and I think he had heard me say it, so it was funny. He was quoting me back, and I was watching. But the way I get ready for a certification is I look at the body of knowledge. There are published standards. These, by the way, are all of the published things. You need 25% of your cert is going to come in cluster architecture right here from these different areas, right? And what I would do is just, if I was self-checking myself, like, how ready am I for this? One, I would make sure I know, like, do I know how to make a role for role-based access control? Can I go do the hands-on? But the other part of it would be, I would look at myself and I would say, okay, manage role-based access control RBAC. All right, I know the tasks that tend to be, can I make a cluster role? Can I make a role that is specific to a namespace? Can I do, and I would think for like a minute, can I talk to this for a minute? Because if I can talk to something for a minute, and I just realized right there that I probably couldn't for that one now, I would feel confident going into my test. I just found a gap in, because I haven't made a role-based access control probably since I did that cert. So now I look at that and go, shit, I need to go study that. That's a hole in my game. So that would go in my notepad. I'd pull up my notepad++. Boom, right? Get my whatever notepad thing that I have. I'll go make a new one. And I would throw that line right there in it. That's something I need to study. And until I've studied that, and until I'm ready, that doesn't come off of my list here. But before I did all that, I would just be throwing stuff in at first. Then I would come here. Can I use kubeadm to install a basic cluster? Yeah, I understand that. So kubeadm is applied to a cluster, but first I have to make sure that I have the swap space set correctly. I have to make sure that SE Linux was off, or that I've accounted for that, because I think newer versions of K8s can work with SE Linux. And I would kind of walk through that, and then I would say, okay, then I would do a kubeadm init on this, and it would build this, and then I would take this file to the other machines. Okay, I feel like I understand what those tasks look like. Can I go look at maybe the explanation here of how that works? This is my explanation right here on the Kubernetes site. By the way, the reason everything I have is tied back to this site is this is the site that you can use during the test. That being said, you only have 2 hours to complete 13 tasks. You don't have a lot of time to be reading. So you have to kind of know this out front. If there's any steps in here or any things I need to be able to know how to do, I need to have them already in my head, and then I need to just be able to reference them quickly if I need. So that would be my one piece of advice, is go through here and see if there's any holes in your game. The next step, the next thing that I would recommend is go to Killer Coda, which is a free site. Again, I keep saying that because it's free. This freaking Rossburger thing. Hold on. I want to find that one that looks like Excite Bike. That one's close. OS2 is close because it almost looks like the Excite Bike. I know. Here it is. That's the one. Peak Slant. I think that one looks like Excite Bike. Anybody remember that game? Jumping over the stuff, and then you use A and B to like go faster or whatever. And then you know what helm is, so you don't. Yeah. So then I would go to Killer Coda. And Killer Coda has a ridiculous amount of practice. And I would tell you, just practice. Again, with the emphasis on not using documentation unless it's that documentation you're allowed to use. And also with the emphasis on, as you're doing your work, make sure you're focused on doing things imperatively and generating them in the system, not copying them, and generate them in the system, have the file, and then modify the file for what you need. And then after you've done those and you feel pretty good about those, I'm going to show you another way that I like to practice. I'm going to go pull up somebody's GitHub I've never seen before. I've never seen whoever I'm about to go check. I'm going to say GitHub, and then I'm going to go look for CKA notes. Right? I'm just going to look for somebody's CKA notes. I don't even know who's going to pop up first. Who is this? 2024, he took his CKA. Somebody's got a guide. Let's go to this guy. Maybe his stuff's good. Let's see. Looks like he's got a little community for it too. He's got a little 40-day challenge. he might be selling stuff, so maybe his stuff's not great. But maybe he does have stuff that's free. Let's see. All right, free stuff is good, but sometimes people, if we just go CKA, just keep looking, you'll find somebody that will just have. This might not be great either. Sometimes you'll find somebody who just has like his examples and things he did, and you can run through their exact same tasks. None of the top ones are good anymore. It looks like maybe people are just making a bunch of money on it now. I actually have the guy's name. I have one of the names in here. Hold on. If we go back here. One of the guys, I know I reference him often in here. Maybe he's at the end. No. I know I definitely had a dude on here. But anyways, here's all these practices ones are on here. Oh, this guy right here. Is it him? Hold on. Let me see if his stuff is still good. Yeah. This is the guy. I'll link this to you if you're still around on the YouTube side. This guy, he just has like these things, and he asks you to do this thing, and then he gives you the solution right here. So you literally just go drop that in, and he generates something imperatively right here, and he does the dry run equals client, which I think you don't need the equals client anymore. I think it's just dry run now, because I think the newer version, but older versions of Kubernetes, we had to do it this way. And then dash o YAML and throw it out in a file, and then go fix the name to be whatever they give you. Because the way that Killer Coda looks, oh, there's one other thing. When you buy that test, you get 2 free runs of 48 hours through that thing. Go do that. It's free. It's the Killer Shell. Killer Shell is the other side of Killer Coda. Killer Coda is the same guys that do Killer Shell, if you don't know that. So you go and you drop in their shell, and you go do all the practice stuff, all the practice environment stuff, and that is exactly the same environment that you will test in, which is awesome, because then while the questions will be somewhat different, the things that you'll be doing are exactly the same. Like you'll have like use this name and use this, and you'll see the exact same thing. So then it makes it a little more I think I don't want to say digestible, but yeah, maybe a little better. Look, that looks like Excite Byte a little bit too. Excite Bike. Anybody remember that game? I can't be the only one. Sending. No, Sending's younger than me. He might not remember it. All right. So that's the kind of things that I would kind of focus on if I was doing that. All right. We didn't get to, so the next one would be like screen commands, and then also we have tmux commands. Those are just ways to go. Yeah, Sending, you were probably just a little younger than that, but hide the pain. That's funny. Sending, can I tell you something that's kind of funny? Every time you say baby L, I know you're referencing the baby's name, but when you talk about taking a baby L or going and working with the baby L, I just think of that newer way where they're like, take the L, like I'm taking the L on the baby. I just think it's kind of funny. I know you don't mean that, but the way you say it, I just keep thinking he's talking about, oh, my wife's taking the L on the baby L now. I'm taking the L now, yeah. So it's kind of like I'm taking the loss, right? Anyways, I don't know. But we could have done screen and tmux. I'll skip those for now, and maybe we'll go work on some DNS stuff in a little bit. But since I think, let's see where my wife is. My wife's a little ways out, so I'll probably take a little bit of a break. Also, I have to work on that paper. Yeah, let's do one more lab. We'll do one more lab, and then we'll call it. There's Colchis. How's it going? We'll do one more lab, and then we'll call it, because I do have other stuff I kind of have to work on a little bit. But I've been showing you guys all this stuff. There are some good course syllabus stuff going on. They're working on the writer's room stuff later. I do have to work on that because we're only 2 weeks out from the start of the automation course, and I'm still kind of looking at, this is what I'm still at right now. I have to start adding in. I have a lot of ideas for what we're going to do, and I don't want it to be, any of you guys that have been through the course know that I don't want it to just be busy work. I don't just want it to be people putting hands to the keyboard just to do that. I want you guys to also sit around and feel like you're getting something out of it, right? Anyways, let's go hop over here. What else do we have? We have, this is what I'll be working on tonight. I'm going to work on fixing that Ansible output tonight too. Our Linux admin stuff, our monitoring. Our environment's all good, all green, right? That's a nice little heads-up display, so that's useful. Logs this. Our new. By the way, me and Treasure worked last night. He fixed this thing. I said, hey, this thing's busted. And he goes, I think it looks right. And I go, no, look again. And he looked again and it was busted. Right here, the Prolog security engineer was going right into the automation engineer. There was no distinction. But now we have on our Prolog website the systems administrator, the security engineer, and the Prolog automation engineer. That's what's coming up. These are free courses. I never charge you guys anything for them. You guys that have been around the Discord can tell these guys, like, I don't charge you. The only person that charges you is if you ask, and their fisherman will say that he's the treasurer and he'll take all your money. But that's fisherman for you. This is the new course that's starting up, Certified Automation Engineer. These are the things that we're going to do. There's a course book being written and in the works by the guys. And then I think if you hit join, it'll take you over to like the join Discord. All right, good. Then we have, that's the book of labs if anybody wants it. It's the only thing that costs anything around here that's on LeanPub. We've got swag. People like swag sometimes. And then what was this? This was, we were looking at the course books. So we were looking at the rework that Colchis is doing on a big mono repo, I think, to republish the book. So that's cool. All right, let's go do this lab real quick. So people that have worked with us before, this is how our labs work. Actually, I can just click right here and do the lab. So here's the lab. I will link it to you guys that want to do it with me. And we will just kind of walk through and do the stuff in Killer Coda. It's free. They don't charge you nothing. I don't charge you nothing. You just go in there and do it. Your team is going to be doing some DNS work, and you have to figure out how to use the tools in your Linux system. So you're a newer Linux engineer. You've mastered the command line. You've mastered working in systems, but now you have to talk with other systems and figure out how our system resolves things, right? So we're going to use host, dig, and NSLOOKUP to figure out what type of information that they can show us about the environment that we're in. Remember, no Linux servers exist in a vacuum. They exist on a network and they do things, right? So we're going to do some stuff and check some stuff out. So I say check host www.google.com. So you're going to feed into the system a well-known web address that is in a human-readable format. And DNS, right, through the tool host, is going to go resolve that name for you. 172, 217, 165, 132 is how you can get to Google. It's also going to give you an IPv6 address, which is a bunch of hexadecimal numbers. And for us now, that's all we need to know. But our system found Google and has a way to reach out to it. That's what we see here. Okay. So then I can also maybe dig Google. And dig gives us slightly different information, but a lot of it's similar. Here's the Google answer, 72, 217, 165, 132. Is that the same thing we saw up here? Oh, it is a 172. There's a one over there. So 172. So yeah, so that found the same answer. And then it also told us where it queried. It queried 8.8.8.8, which is a common DNS via Google, right? That's a common external, anybody can hit that Google DNS right there, and it's considered always up, right? So I can dig it and get some commands and some interesting things. And then I come down here and I see, how many A records do I see? Well, I have one A record, and it is 172, 217, 165, 132. Sometimes more A records pop up. Depends what's being configured. Depends what you're looking for. What server was used for the DNS query? Again, it's right here, 8.8.8.8. Very common. And then I say, can we find how our system knew to use that? Like, how would any Linux box or how would any server know to use that address? Well, we cat etcresolve.conf, and here it is. There's the name server. It'll use 8.8.8.8, and then it'll use 1.1.1.1 if it can't find that. Sometimes there's timeouts. Sometimes there's round robins. You can do minimal configuration inside of this file, but it's not super robust resolving process that's used. You'll find it if you ever go mucking around in here and doing different stuff, and then you mess something up and you're like, why didn't it just go to the next one? Well, it'll just crap all over. Like if I change these two, this will just crap all over the place and won't work, and you're like, really? But anyway, so there's some things that you can build into it, but we can also go look, and there's our resolve. We threw out the output of the name servers into root name servers, so our system would be happy with us. And then we're going to do a traceroute. Traceroute's an interesting command because traceroute assumes that everybody between here and there are allowing ICMP messages to be sent. And you will find very quickly that messages and servers out on the internet are not responding to ICMP ping. This set of dashes right here is a timeout, or these set of asterisks. Those are a timeout. Some device in there didn't want to let us know who it was. Because what traceroute does is it does ICMP pings to the next hop as it goes through the system, and then it maps them all the way back for the communication channel all the way to the IP address that it resolved, which is right here for Google. Is that the same one we resolved earlier, or is that a new one? By the way, they change often. That looks like a new one, 142.251. Oh, I've cleared it, but host 172.217, those are different, right? So it's found a different way to get over there. And then how does it finally get there? And does it finally end? In this case, it finally ended there where it expected to, as opposed to here where host is still showing. Oh no, we're resolving different ways. These are things to notice, right? These are things to watch if you look at your tools and see that your tools are behaving differently, right? This tool is definitely giving me a different known address than this one is for traceroute. So what's traceroute looking at? Shit, I don't know. We could dig in on what traceroute's doing, right? We could use strace and see. We can. This is gonna blow up my screen. But we could go back as soon as he's done. So he's gonna give us our whole trace, and then we could go and dig through. He tried to use 1 up there, and then he used 8. All right. Let's do something else here. We did this earlier. -C will summarize this. So when it's all done, it'll tell us all the calls it did. It'll do kind of like a little human readable output for us, which is kind of nice. We'll let this run. I think this is using... These are all the things it did. All the different calls and stuff like that if we need to dig in. But I think it was using 1.1.1.1. It definitely used 8 at some point, but it also was making a call. It might be easier to throw that to a file and then parse it through later, right? We don't normally look at stuff that's on a tiny screen like this. Anyways, the point is we can go see what's going on. We can dig in and we can see the actual system calls that were happening, and then we could try to figure out what a tool was doing, right? That's not really that important to this, but it says right here, what are the types of addresses returned by the host command? There was an IPv4, which was in a dotted decimal notation, 32 bits long, but it was 4 different dotted decimal, it's 4 digits between 0 and 255 in each of the octets, right? And then the other part of it was IPv6. There was an IPv6 address sent as well. That came out to us in 128 bits, but those 128 bits were represented by up to, that would be 32 hexadecimal, right? Could be less than 32, but it could be up to 32 hexadecimal. Yeah, because 32 hex is 4 for that. Yeah. So 32 by that would be 128, yeah. What answers did you get back from traceroute? Well, we saw all the devices that wanted to respond to us, but then what does it mean to get a bunch of those? It's either a timeout or it's just not responding. Typically a timeout from not responding. What's the default host lookup order in etc NSSwitch? So this is interesting. So we'll cat etc NSSwitch.conf. This is the way that your hosts are looked up in your system. So my system currently looks at files first, and then that DNS resolution second, only if it didn't find something in the files. So we're going to prove that here in a second. And then I said, what happens when you put the Yahoo address in etc host for Google? Why did that change? So let's go do that. Actually, that's this next part of this lab. We're going to break something here. We're going to go cat our etc NSSwitch out, and there's our hosts. And then we're going to curl Google. And we're going to see that there's a bunch of Google words. That's what's important. There's a bunch of Google words here. And then we're going to do a host for Yahoo. And we're going to get some hosts. And then we're going to echo that host for Yahoo. This is one of them. And we're going to throw that in here as Google. And then we're going to curl the Google site again. And look at the Google site going over to Yahoo. That's a problem. Why is the Google resolution over to Yahoo now when a few seconds ago it was over to Google. Well, if I were to cat out hosts, there's Google down here, but it's pointed to the Yahoo resolver, and we know that it uses hosts first. We saw that right here. It used hosts first, so use the host file first and then DNS second. Now we're going to switch that. We're going to use DNS first. So we're going to vi etsy nsswitch.conf, and I'm going to tell you best practice is this. Copy this file off before you touch it. And you don't have to do all this, but if we ls-l on etsy nsswitch, right, now we've got the nsswitch.conf right now, and then we've got one backed up for today. Sometimes I put .orig on there or whatever. That's vi etsy nsswitch. And we're going to come down here, and we're going to say yyp, and then we're going to comment that one out, and then we're going to just flip DNS and files real quick. So we commented out the other one, so it's not being used. We're going to only use the one. And then now when I go curl Google again, we're going to see Google again, because we used DNS before we used our host file, right? And that's what that was to show you, that your system resolves in a certain way, but it's a predefined way that you can change. You have all the power in the world, guys. If you're a Linux admin, you literally can do whatever you can imagine about in the system, including installing programs that change the way it works, including installing a new kernel and breaking the whole thing. You do whatever you want. That joke about the rm-rf, you can do whatever you want. rm-rf asterisk or / to just remove everything, you can do that. You're root. Nobody's going to tell you you can't do that. So look at you learning Linux. We come over here and I say, what are the common ports for DNS and why does it use both TCP and UDP, and which protocol is used for which type of traffic? So the reason this is important to know, so common port for DNS is 53. Route 53 is an easy way to remember that. Route 53 is the DNS for AWS, so it's easy to remember that port 53 is the default. But your system uses both TCP and UDP. And it's like, well, why? Well, because it tends to be, and also why would I want to know that? This is an important one. If you're ever setting up a network policy inside of Kubernetes and you're allowing port 53, you need to allow it for both TCP and UDP. Otherwise, everything can break. And when I say everything can break, what I mean is you will not be able to establish connections back to like your core DNS, because TCP is typically used for control, and then UDP is typically passing messages, right? Because UDP can just pass messages quickly, and then TCP can be used for control of asking questions and validating that you got a response or whatever, those kind of things, right? I say right here, if you filter traffic and only allow UDP or TCP on the DNS port, what types of name resolution issues might you run into? Well, I've done this before. If you block UDP, you don't get responses anymore. And if you block TCP, you can't request responses anymore. So one, you can't request, and the other one, they can't answer you even if they wanted to. What's that show? I never got into WandaVision, but I remember there was this one scene that kind of came around, and you guys that saw it probably know what I'm talking about, where they're like, with a word of this guy's mouth, he could destroy you and everybody. This, and she goes, "What mouth?" And his mouth is gone, right? Like, I didn't see it, but I saw that scene and thought it was kind of funny. This is the same thing. Like, if I don't allow UDP back in, and that's the way it's going to talk back to me, like, it's like, what mouth? You can't tell me anything. So if you filter traffic, you need to make sure when you filter traffic you understand the implications and then why we have to allow both TCP and UDP. I'm going to tell you right now, if you don't allow TCP and UDP when you do any kind of traffic filtering and then you allow it in, you'll break everything. If you say, hey Scott, could you show me an example of filtering properly? Yeah, I actually have a lab on this. One of my, let me go to my Kubernetes labs real quick. Hold on. Let's go in Kubernetes labs and I'll show you guys one that I think is useful. We're not going to go through the whole lab right now. It's in my Kubernetes labs. It's in my 3-tier application. And this comes from a presentation that I did. I think it's up on YouTube somewhere. But this is also in our Discord. And what I wanted to show you is if you do all these things, I might have to do all these things to get to that page. Yeah, well, I don't think this will finish. Yeah, it'll fail. Let me show you guys. We'll go through it real quick. We won't do the whole lab because it takes me too long to talk about it all. But we're going to build these namespaces. We're going to create a secret. We're going to get the secrets to see that it's there. We're going to go look at our deployment of a physical volume and then a physical volume claim, right? So we're going to build a claim and all that stuff. Create it out, go look at it, see that it's there. We'll ingress Docker PS, make sure that those things are there, and then we'll make sure everything's there. Okay, good. None of this matters to what I'm about to talk about. I'm just going through it real quick. We're going to set up a MySQL app real quick. We're going to make sure that we can read the simplest little MySQL app inside of Docker, right? And it's using Flask, which is super easy to just render some basic little, on a port, some index.html. And I have the index.html in there, and we're just going to build this whole Docker thing real quick. So don't worry about all that unless you care about building that stuff. That's like stuff you can go find on the web if you wanted to. You get a little error because we're pipping as root or whatever. Who cares? Now we're going to go push that over into our local repository that we have. And then we're going to check it. And then we're going to run this and build it. And we're going to expose the app. And then we're going to make sure that we have the app. Make sure that the service has a proper backend endpoint. It has all those things. Again, this isn't really what we're talking about here. I'm doing this quick. So now on the outside, when I hit my application lab mine test, I get that I could read a Flask app from my little Docker, right? So Kubernetes to deploy a Docker Flask app that we just built and then feeds like an HTML page. Super simple stuff, right? And we're going to create this MySQL thing real quick. And then we're going to go in there and make sure that it's got a backend. It doesn't have a backend yet. Doesn't have backend yet, so it hasn't finished setting up yet. There, now it's got a backend to the pod, so it's up. Now we can go look and see everything good. We can run a quick little tool, and then once this downloads, we'll be able to in there run our very secure. We're just gonna connect real quick, make sure we can connect. Again, none of this stuff matters to what I'm talking about here, but I just have to do it real quick to get to the part where we protect it. All right, so now we do some MySQL. We're gonna copy these values all in and create a quick database. Boom. Philip Devnull and Het Tanis are the two users, and then we can go and we can exit. And now we should just be able to read those users. So there's the users, persons, and then Philip Devnull. Did it not take the second one? Oh, apparently I didn't get Het Tanis in there. I don't care. All right, so we got the one user. I don't care about the other one. And now we're going to go read Docker. We're going to deploy this. Oh, get out of here. Read Flask Docker. We're going to go look at it. Now, this is how you read from that, and the read is super simple. We'll see it right here in my... Yep, so here we're going to go do a SQL read. There's something I would normally not do. I hard-coded these in. I would normally use them as secrets, but we're just going to do that for now. And then we're going to come down here, and let's just install this and build this real quick. Here's your HTML that's just going to read through the list that's given. Oh, actually, this might error because I don't have a het in there, but whatever, I don't care. It'll just not have anything, I don't care. Let's go run it. I've actually never tried to do this without that. All right, so let's go and build our service out. Redo our ingress. We're going to delete the ingress. We're going to make a new one, and then we're going to make sure that we can read the curl. Oh, did we not create that back up and then go look at that? What's going on here? So here it is. It reads the Flask app. It was taking a while to come up. And then now it went and it found Philip Devnall and it made a little, it read him out of the MySQL, fed him through onto a web page that people would see or whatever, right? All that to say, now we're going to secure it. And when we go to secure it, we're going to go look at this policy for denying. We're going to deny everybody in to that network of data 1, which is where our data sits in that MySQL. So we're going to do that real quick. We'll create him. And then the other one is this policy allow. I want you to see the policy allow. And on this one, we're going to only allow in there port 3306. All right. And we'll create that one. And then we've got to do policy deny and allow. Did I not? Oh, well. Make sure it still works. Still works. That's funny. I forgot. We actually don't have. We don't have it in there. I thought we had DNS in here, but we do not. So we apparently don't need DNS for that app. But I would have typically had to have ingress here. Allow. That's actually what I was doing it all for. So, never mind, guys. Don't even worry about what I'm doing over here. I thought I had in here that you had to allow DNS, and where do I have that? I don't remember where it is. This is all the old stuff here. Anyways, you can see all the stuff. You can break everything. You do whatever you want. Okay. We did the DNS though. We worked with DNS, and then when setting up DNS and using it for deployments, why is it so important to understand client timeout? Why is it important to know that you don't control client timeouts? This is important if you're doing stuff out on the web, right? Like you're just deploying stuff out in the world. Maybe you're using AWS, and then you're like, hey, I'm going to be slick. I'm going to use AWS Route 53 to cut over my web page to a new web page. And I'm going to cut over a new service so you hit this other API, but I'm going to do it in DNS. The thing to understand about client-side DNS is this. If a client doesn't want to play nice, they don't have to. So what I mean by that is I'm connecting into your server on this API that I've resolved from DNS somewhere, and you cut over the DNS, and until my client clears his cache, which tends to be 5 minutes, that's kind of like the common contracted time that everybody has chosen to use, I won't cut over to your new API. However, that being said, if I wrote my client in such a way that I don't ever check, again, I just keep that same DNS, I may never change to that new DNS. And some clients, I mean, kind of like a hard timeout for most people is 24 hours. But my point in saying that is, if you cut things over with DNS, you don't control the far end clients unless they're like something you own within your organization. Like, oh, hey, all the people that connect into this, actually, I have an access to go like reset their client or something. Sure, if you have that kind of power in an organization, you can do that. But otherwise, you can't assume that DNS for sure is going to flip over the way that you expect it to, because you don't know how the clients behave. Well, it's not that you don't know how they should behave. They should reset every 5 minutes and recheck. But if they don't, you can't force them to. You don't own that part of it, if that makes sense. So, because DNS is how you present out. So like if I go, let's go to, what's console AWS? What's AWS console login, right? Something like this. I go log in. Where's my sign into console, right? I go log in here as some user, right? Who am I on here? I don't even remember. I think I'm this guy, right? Something like this. I don't even know if I'm gonna be able to get in this. Am I all the way up there? Oh, I don't know. That either locked me out forever or just something. Apparently it let me in. I was gonna keep guessing until I got in. So this is my actual AWS account, right? And apparently I have a whole bunch of stuff that I don't have access to, right? Which is fine. Guys, I don't want access to none of that crap. But what I do know, I don't have billing. But what I do have access to in my environment is my, dude, why don't I have Route 53, right? I do have this access. Where are my hosted zones at? I go like prolog.org, and here are my resolved names back, right? So here's my A record and where it goes and who is my name servers. So if people are trying to resolve to me, how are they resolving to me? And then if I go to any one of these, like my prolog A record, I don't have to edit the record. I can just go look at it. I can see where it's pointing to, right? And then in this case, I point over to my AWS CloudFront. What was I bringing all this up? I don't even remember what I was bringing all this up for. Oh yeah. I can cut over between, so this prolog.org is looking to an alias CloudFront distribution that I have that backs up, or it caches all of my stuff up from my home lab, right? So when you guys see the prolog site here, not that one, this one, you're actually seeing an AWS CloudFront cache of my stuff, right? Unless you go directly to it. If you know how to get directly to it, that's fine too. Some people know how to get directly to it for testing and stuff. But where I'm going with that is I can cut this over whenever I want. But if people keep going to that old one because that's the only one that they know and their client's not going to get rid of it, I can't delete their knowledge of this, is my point. I have no way to do that. Good, proper rules and hygiene of the web say about every 5 minutes it should cut over. But I don't control that, is my point. So that's an important thing to know about when you're working with DNS. You can, DNS is a fantastic way to cut AB and canary deployments and all that kind of stuff. It's awesome. You can round robin, you can do regional DNS. There's all kinds of stuff with DNS you can do. But you can't control what a user knows once they know it, is my point. Yeah, Billy Bob. So CloudFront is it's not really a proxy. What it is it's what we call a, at the end of the day, it's a cache, but it's a people call them content delivery networks, CDNs. You'll hear them called CDNs often, content delivery networks. And what it is it's just basically a worldwide presence in AWS that it goes and pulls my information, and then it kind of stands out in front of anybody can query and do. Like if you go to our webpage right now, our Prolog page, you can do whatever you want here, but you're really hitting a cache of the page from content delivery network or edge caching courts. You could think of it like that, yeah. And then the only thing that comes back to us is if you actually query something like this and it doesn't have a query of the result. So like me or one of our other guys, you'll get ours real quick because those are cached. But other people, it'll have to come back and get their, if you know any of their certificate numbers, because people that got certificates with us, the people who got certificates, they can put that on their resume, and then it shows that they actually did this. They also got a pretty cool little certificate with it as well. So yeah, that's what it is. And then I'm trying to think of what CDNs exist out. Akamai is probably the biggest content delivery network on planet Earth, if I had to guess. CDN for all of like Microsoft updates is all Akamai, and then they also used to do firewalls for me. I used to do web application firewalls through them with one of my day jobs back in the day when I was a red team lead. I used to do all the firewalls for my company through them, which was weird because you go, well, running firewalls isn't really a red team thing. Yeah, I know, but it fell to our team. And since I was the tech lead, it fell to me. Kind of a hassle, but it is what it is. All right. Guys, it is 4 hours and 15 minutes in. I'll probably call this here. I got a lot of work to do today on college stuff and just I got to work on my dissertation. I will be on in about 7 hours. I don't know if I'll be live, but I'll be in the Discord in about 7 hours. We'll be doing our work. Sometimes we do that live because that's kind of a fun little thing for people to watch. But yeah, we'll call it here. I think we got a lot done. Hopefully you guys learned some stuff. Hopefully you guys know that there's a place where you can go hang out. Like our Discord is available for anybody that wants to hang out there and do Linux or Linux adjacent stuff. We have, just everybody hanging out down in there, and most people are pretty helpful. Some people are pretty negative, but I mean that's kind of life, right? You're gonna have negative people, and
we stream learned a lot of stuff. Cheers.
Kung Pao Jeff. Hopefully this stuff's useful to you guys. I appreciate that. But yeah, look, people are down there talking right now, working on stuff. You guys can use the servers pretty much whatever way you want. There's a bunch of events coming up. You can always check events in Discord, and they're free, right? We don't charge you anything. You can go hang out, just mosey on in, and you don't even have to introduce yourself if you don't want. Just hang out. So, yeah. Phi Linux. I hope this stuff's useful to you guys. So let's go hop on. We'll raid somebody on the